Welcome to Imagine 2025. The keynote will begin in 5 minutes. Please take your seats in the auditorium and silence your mobile devices. Welcome to Imagine 2025. The keynote will begin shortly. Please take your seats and silence your mobile devices. Please welcome Edge Impulse co-founder and Qualcomm Vice President, Zach Shelby.
Hello, everyone. Good morning. Welcome to our 5th annual Imagine. Edge Impulse is only a little over 6 years old since Jan and I founded the company. So it's amazing to think that we're already 5 times organizing this conference where we bring together leaders across the edge AI industry, partners, top developers, customers, and really cool brands that are here to learn about the latest applications for the technology, what people are really building, what people are excited about, and where the technology is going next. So I want to ask a quick question, because I know there's at least one person. How many of you have been here all 5 Imagine since the very beginning? We've got Evgeny, Kwabena, Adam. I've been here. Jan's been here. Oh, you missed the first year because of COVID. Okay. So you guys even beat my co-founder, Jan. We organized the first Imagine in the beginning of, or towards the end of the pandemic. So we actually decided to pull off this conference. It was Adam Benzian, who led our marketing team at that time, had the crazy idea that, you know what? We need to own the conference for Edge AI. We need to bring everybody together in the ecosystem and learn from each other. How do we build the most amazing solutions, and how do we go to market together? And I think we've been extremely successful in doing this. We built an entire industry. So I want a round of applause for everyone that's been involved with this. This is what success looks like when you go build things together. And so we're only going to be doing more of this. We're going to go bigger. We're going to go better. And I think you're going to see that this year with just the energy, the quality of speakers, all the cool demos that we have outside. Live from the Computer History Museum, we have a very cool set of people. I'm going to show some of the logos of the companies that are here, because I want you all to come away from this feeling like you've had the best networking of the year. Imagine's very much about networking together, getting to know other people in our ecosystem. So if there's somebody that you want to meet, something that you want to achieve, please come talk to one of my team. Anybody from Edge Impulse will help you meet the people that you need to here at Imagine. And this year, we have a very special theme. This year, we're going to talk about cars. I'm a car guy, so really excited to talk about everything related to fast cars and AI. And my job as CEO or co-founder is to draw really cool car cartoons. This is my biggest value add. And so you're going to see all of my car cartoons. If you want one, please email me. I charge money for doing these, but I will make you your own car cartoon. We've got 12 speakers today, an amazing lineup from every end of the technology. We have everything from ultra-low power, Arduino, OpenMV, all the way up to canonical, right? Super high-end Linux. Everybody is here talking about the whole end of Edge AI. So please enjoy all of our speakers that are coming up. I'll introduce a few while I'm talking. And most importantly, right, my job is to make fancy-looking PowerPoints and entertain you on stage. That's the easy job, right? The real job is all of our engineers who have built 20-plus very cool demos from across the industry. We have our closest silicon partners, OEMs, ODMs, module makers, disties, AWS, right? We have everybody here showing off the coolest applications in Edge AI. So at our coffee break, at lunch, during our networking, you'll have a chance to go to the showroom and hang out with the people that are really building stuff. So please do that. Feel free to dive into what people are building, how does it work, ask questions, and do business together, right? This is the place to start working on the stuff that we're going to show next year at Imagine. We have over 300 attendees coming today, so some people are still on their way in. It's going to be a full house as the day goes on. We have thousands on live stream, so Imagine's always a live stream event, so anybody can join the event online. We have thousands of developers that join every year to watch, and we have a Ferrari. The Ferrari has a story, right? This Ferrari 268 GTS supercar, 820 horsepower, it came here for a reason. I'll get to that a little bit later. A bunch of the people that are speaking today actually had a part in helping make that car come true. And so I wanted to bring that car here for everybody to experience what it takes, what it means to build a supercar, and what's all the AI technology that goes into the process of making that happen. Now, I want to go way back, right? To the very beginning of TinyML. Here we have Jan, Fiat 500, Young Boom. When Jan and I met 12 years ago, 10 years ago, he drove a bike. He didn't drive cars, so he was very tiny. These days, Jan drives a Tesla, but that's a little boring, so I put him in something cooler. TinyML started back in 2017 when we began to prove how do you run machine learning on microcontrollers, on small devices. Back then, when we talked to people, we thought it was impossible. When Jan first heard that we had a very cool engineer from Taiwan, interestingly, Neil Tan is his name, from Taiwan, one of our developer DevRel engineers. Neil told us that, you know what? We could do a project where we can run this machine learning stuff that I've been doing for robotics on big GPUs. We could run this on a little microcontroller. Why not? It's just math. And Jan was like, BS, I don't believe you. It can't be possible, right? Back at this time. It's almost 10 years ago. And Neil said, yeah, it is possible. So he wrote a little open source project called MicroTensor. Some of the coolest stuff starts as open source projects. And MicroTensor showed that we could go from the TensorFlow world, a big ML, and we could compress that down to the math that we could execute on a microcontroller in real time on an FPU with no other acceleration. So this is just standard microcontroller stuff. And that blew everybody's minds, right? That helped us begin to get the confidence, together with Google, Qualcomm, ARM, Microsoft, and many others, to go and build an entire movement around what we called TinyML at the time. And we started the TinyML Foundation at Evgeny back in 2018, if I'm correct. We started a TinyML Foundation around this, a movement, right? It's the very beginning. The problem was the tools that we built ourselves, our open source tools, the TensorFlow tools, stuff from Microsoft, stuff, it was completely unusable. This is the worst tool stack that we've ever seen in our lives, Jan and I. We're like, wow, this is really fun, but this stuff is so nerdy, so difficult, it breaks. There was one guy at Google, in Dan's team actually, One guy at Google who was able to train a model. And it was an MNIST GIF, or MNIST like tiny classifier. Some people remember those days, right? We had the one trained MNIST demo. And that's what everybody showed on microcontrollers. Didn't matter. There was no real data, no real sensors. And that was so frustrating for us, right? So the story of Edge Impulse, how this all started, was that Jan and I almost gave up. We were to the point of frustration with all of this ML stuff that we're like, this is never going to work. Developers are never going to be able to deploy any of this in real production anywhere. It's so difficult to use. We can't have one guy at Google do all the model training for everybody in the world. It's got to be easier. And so it was actually over sushi and sake here in the Bay Area that we finally realized ourselves that, hey, maybe it's a persona problem, right? Maybe we're making the tools for the wrong people. ML researchers make tools for ML researchers, right? You write the code, you get your paper published, you throw the code away. It's going to be difficult. It has to be difficult because we're super smart mathematicians. But most developers, right, the millions, tens of millions that work on industrial systems, they're not mathematicians. They don't care about writing research papers. They just want to get the ML to work for them. So that's how Edge Impulse started. We decided that we're going to build a tool stack that serves all the engineers, all the developers in the world building real industrial systems. And so that was 2019. We built state-of-the-art technology, completely new developer flow with that philosophy in mind. And TinyML back then was something very different, right? TinyML, the state-of-the-art, the coolest, highest performance things we did, 100 kilobytes of RAM. Microcontroller only, right? We were really focused on the microcontrollers, the smaller the better. Completely manual data collection. None of this stuff does transfer learning. If you want to build a model on sensors, you have to collect all the data from scratch. Super difficult, right, to get real data from real industrial equipment. Most of the applications that we worked with back in these days, this is 6, 7 years ago, classical ML, neural networks that are shallow, working on sensor data, a lot of health algorithms, working on CNN audio and image classification, simple classifiers, right? All of this is now state-of-the-art, shipping in multi-million unit volume. So I think about this as like, in TinyML, we've now gotten to the point where we're shipping Fiat 500s in millions of units. This is all mature market stuff. Edge Impulse is continuing to invest in this. So when we hear Jan's talk later, we'll hear about all the cool technology that we're putting into play in this space, so how we can do more with sensor data, how we can get more performance out of real devices. And we're going to be shipping a lot more of these. But Edge AI has become something very different. So this is our friend Fabio, CEO of Arduino. He'll be up speaking after me. I've done cartoons for everybody, don't worry. Edge AI has become something very different, right? Us as an AI industry, how many of you are at Embedded World this year? Edge AI was everywhere. You couldn't turn a corner without seeing Edge AI. And Edge AI was in everything from small embedded modules to massive industrial PCs, gateways, edge servers, you name it. Edge AI is everywhere. That's the theme of our talk this year. And it's here for a reason. People aren't doing that just for fun. It's not just because of hype, right? We have customers in the field demanding that we build the technology that they need to solve their problems. And what customers are demanding today at the high end is a Ferrari. We can't build Fiat 500s for these customers, right? We need to build Ferraris as well. And boy, the requirements are out of this world, right? The things that we have to do now at the high end are really extreme. Gigabytes or even hundreds of gigabytes of RAM. NPUs with 100 TOPS, and I'll talk about something even higher performance later today. Completely synthetic data. We have customers coming in that have access to no data. How do we data completely synthetically? We have a really cool demo from Ivan, our Norwegian ambassador, talking about all the work he's done in synthetic data generation. Go check that out. No data, right? We have to do zero-shot solutions for solving problems. And the applications we're expected to support from the Gen AI world coming in at Edge AI are pretty extreme. Completely natural language human interfaces, right? People want to speak to machines. Not just LLMs, but LLMs with RAG, right? These LLMs have to do something useful for industry. A chatbot is not that interesting. We're getting asked to work on vision language models, and then for robotics, we're expected to deliver vision language actuation models. That's something completely new for most of us in this space. And this all has to work with industrial reliability And it has to be as low power, low cost, and easy to use as an Arduino. And so Fabio from Arduino will be talking next about this low cost, easy to use experience and how this works with Edge AI. But this is a lot of work that we still have to do as an industry. So the takeaway I want everybody to have here is that we have to step up, right? As an industry, we have to do a lot more to deliver this vision. And we'll make some announcements at Edge Impulse, some cool new tools that will help enable people to do this on new hardware. But there's a lot of work still for us to do over the next 2 years. And the thing that's inspired us, why we think Gen AI is coming in deeper and it's here to stay, is that over the last 18 months, the quality of large language models has increased 9x compared to the baseline ChatGPT. This is the original ChatGPT, GPT 3.5 Turbo, 175 billion parameters. Now we have models in the class of 40 billion parameters down to 10 billion parameters that have 9x better model quality on a quality index. And we expect at Qualcomm that this is going to just increase and continue. So this tells me that if we can do models in the 10 billion to 40 billion parameter range, we can do almost everything that's useful in the Gen AI world on the edge. And this is really exciting. So this tells me that Gen AI is also maturing to the point that we can start to apply it in real products. Now, Gartner is saying that Gen AI, Edge AI, is on the way to maturity. We're just 2 years away from being a mature market for this stuff. So that's why I say we only have 2 years to get our solutions in shape and deliver on this vision, this Ferrari that I was talking about. When we started working on this talking about the breadth of products that we've seen, we worked very much in the tiny space. This is HP Poly, where we've shipped in headsets, earbuds, consumer equipment. We have another partner here. The CEO of Hydrostasis will be talking about what they're doing for monitoring the water levels, the level of water that you're drinking. Are you having problems with too little salt, too much salt? They'll talk about the device that they've developed with embedded processors and Edge Impulse a little bit later. Smart grid. We've done tons of applications on monitoring the grid with 10-year, 20-year battery life, super embedded devices. Smart pets. We've done pet trackers, pet feeders, very low power, very cheap. And a lot of extremely embedded cameras. So later we'll have Kwabena from OpenMV talking about all the cool work that they're doing in embedded cameras. And I have a bunch of toys here. I love my toy table. This is how small cameras get now. That's a complete high performance. This does full object detection at full frame rates, 30 frames per second. This is running in a LIF embedded MCU with acceleration. Kwabena is going to tell a lot more about what this thing can do, and you can see the demos outside. But this is how small embedded cameras are getting. We've done a lot of this. We have another great example at the LIF table. This partner builds a satellite-powered, battery-powered camera. This thing runs at 100 milliwatts of power. You can put it anywhere on the Earth, point it at something that you want to detect something's happening, you want to classify a problem, you want to go look at visual inspection on something extremely remotely, you can do it with this little box. So there's another demonstrator outside in the showroom. We're only going to see more of these super low power cameras. But now, going forward with the Edge AI requirements, we're getting pulled into completely new spaces. Industrial robotics. We're seeing more and more applications where Edge Impulse is getting asked to do more. Humanoid robots. So I have a guest later. We'll talk a little bit about robotics and what's happening. We're getting asked to work on humanoid robots. Very high end, very high performance. Lots of new model expectations. And of course, automobiles, our theme today. We're getting pulled into not only manufacturing, but into the cockpit itself. How do we improve the security, the safety, the knowledge of what's happening in cars? We're getting asked to work on this too. And I have a really interesting speaker from Globalsense coming to talk about what they're doing in car analytics. And I want to show a little video. So we actually had them go out this morning and work on the Ferrari while we were setting up the show. They build this little audio-based sensor. The US's largest auction houses use them to do audio analysis of the quality of cars. Very difficult to inspect a car quickly. They can do this very short amount of time with this thing. So they actually went and hooked this up. Let's see if this video works. They went and hooked this up and did a real analysis on the Ferrari this morning. It's brand new, so I hope it's not broken, or that I broke it. So Saeid and team, I expect full analysis by lunch of any problems with the Ferrari. We're going to hear a lot more about what they're doing with this. But these kind of automotive solutions over the top using, in this case, microcontrollers, advanced audio, some of our silicon partners, like Sentient, being used to go and enable these types of products. And at Agyeman, we're being pulled into every angle of the automotive manufacturing industry right now. So that's what I'm going to talk about next. Manufacturing has rapidly modernized. We're seeing so many changes in the automotive industry. This is an industry that used to be boring, and it's now exciting. It's one of the leading industries automating. They're getting geographically distributed, having to modernize for EVs, automate everything, improve quality, improve inspection. And many of the people that were used to be doing these quality inspections for tier 1 suppliers and OEMs, they're retiring, right? We don't have that skill set anymore. We have new workers coming in that don't know what the quality should be. So that's being replaced now by sensors and AI to go improve the quality at much lower cost. Let's take Mullertech as an example. This is a global tier 1 supplier of plastic parts for luxury car makers. Mullertech used Edge Impulse in our FOMO-AD algorithm, this FOMO anomaly detection, visual anomaly detection, to go and deploy monitoring stations on all of their plastic parts as they come through and tell whether there's a defect, a misplacement, any small thing we can detect. And this very quickly saved them over $1 million a year in costs that they were getting fined by the manufacturers. Improved their quality, reduced their downtime, enhanced their margins overall. And we're going to see many more cases like this coming from tier 1 manufacturers. IDT. IDT is a system integrator and solution provider for manufacturing. So we're going to have Margherita talk later today, Ms. Margherita, talk about what they're doing for the luxury car manufacturing industry. And this is the reason that we have the Ferrari. Margherita's company went and built a solution to do the quality control on the battery cells going into that exact car. So I actually drove her over this morning in the Ferrari. She had never been in that car before. Super exciting. Her company helped build the quality control system for that car using Arduino. So this comes full circle with the Arduino talk next. Suzuki. We've had Suzuki use Edge Impulse to go and replace quality engineers that use their ears to detect when a wiring harness came together properly. It's super interesting. When you connect a wiring harness together in the factory, it makes a sound. These engineers, they knew when that came together and the sound was good, and they knew when the sound was bad and the quality was a problem. And so what we did is we used those engineers to label the training data to train a custom audio classifier for good and bad quality. And this we could prove that we could replace, improve faster throughput, better quality. We could check problems that maybe the engineers couldn't hear, and we could do this even when engineers change, and we lost that generation of people. Super interesting use case with audio. And I believe we're going to see more of this. Vision, audio, sensors, multimodal used in a factory setting. Another global supplier making actuators using Edge Impulse with multi-sensor fusion to understand the quality and the predictive maintenance of their products that are going into the car. So not only are we getting into the manufacturing side, we're being pulled into the automotive space directly in the car by tier 1s. We'll hear more about this. This actually came in together with our partner Microchip. So we're working on this together with Microchip. And finally, we have a German luxury automaker starting to use Edge Impulse with the cameras for security that are on the doors, the license plate, the front. And using these tiny cameras, we can look at potential threats in real time. And this has impact not only for the car owner's experience, but also for things like insurance, accidents, et cetera. So car makers are starting to embed this type of AI technology directly in the car. And this brings me to something really exciting, new product announcement. So because of all this, right, all this demand that we've seen from manufacturing, not just automotive, but much more broadly, we're announcing a new product from scratch. Together with Qualcomm, we're building something called visual inspection. And visual inspection is cool because for the first time, we're going to be bringing a full solution to market. Today, Edge Impulse solves maybe 20% of your problem on the factory floor. You have to build the model. You have to build the system, all the apps. You have to manage this end-to-end, do IT. There's a lot of work that we don't provide. With visual inspection, we'll be solving 90% of the problem and working with system integrators to get the last mile to the factory. And the way that visual inspection works is that we're bringing state-of-the-art AI-based machine learning together with modern quality management. And we're doing this in a way that's distributed across the edge on the newest hardware. We're doing it with all of our camera, edge box, and AI appliance partners so that we're able to improve the yield, the quality, and the visibility, both on the factory floor. So if you think about this, there'll be cameras with a station for the factory workers. They'll see exactly what's happening, right? When something's marked as problematic, they'll see it, they'll be able to understand the data, as well as the analytics for the back office. We can manage any number of manufacturing lines, any number of sites from one platform. And this will be available both hybrid cloud and completely on-prem, no internet required. And a lot of benefits to this, right? We can get these to market much more quickly. Easy onboarding, QR code onboarding of these cameras into the system. We're having no-code model libraries for people. So we're pre-building all the sets of algorithms that you need for different types of cases, like PCB inspection, food and beverage, plastic parts for automotive. So we'll have formulas that are ready to go. And we have an automated process to fine-tune those models. We keep the human in the loop, right? This isn't about full automation. This is about helping the workers on the floor to perfect their process. And then finally, we're integrating with the enterprise side. So we're integrating all of our analytics with ERP systems, PLM systems, quality management systems. So this will be fully factory integratable. And this is something that our system integration partners are really excited about. They'll be able to bring this to market a lot faster. And we have a couple partners that we're launching with. We're going to be doing this across our entire ecosystem. But launch partners include JMO Kodico. So they just gave me this brand new camera. This is a brand new, this is a Dragon Wing IQ6-based industrial camera. This has a camera built in, and it has connectors for 2 additional cameras off the side. So this is one of our first launch products, so a very industrial camera setup. And Advantech with their new iCam 300 industrial camera. We've used this for 2 years now already, and we've been deploying a lot of these. Now we'll be supporting visual inspection on this device as well. And the number of use cases that we can solve here are extremely wide. Everything from PCBs, automotive parts, food and beverage, label and SKU verification. So if you have applications that you're seeing demand for, please come talk to us. Alexi, who is our head of product, talk to Alexi. He's really interested to hear about more use cases for this, how we can go help. And it's not going to stop at vision, right? We're going to expand this for audio, sensor, multimodal. We're going to cover all of the different inspection solutions that are out there. Built on Edge Impulse, but a completely new product. So we'll talk a lot more about that. We're now launching our new YOLO Pro model into production right now. So YOLO Pro is something we've been working on for a long time. This is a state-of-the-art YOLO class model that's been designed, trained, tested completely from scratch at Edge Impulse, solely for the purpose of edge compute deployment and industrial applications. So this is a really state-of-the-art thing that we can control and make sure that we're fine-tuning this for exactly the targets. And so we have 6 targets that we're launching with. Jan's going to talk more about this later and go into all the details for the new YOLO Pro. We're also launching our new VLM cascading technology. So I talked about Gen AI coming into the space. We're embracing that. So from this day forward, you'll be able to deploy multi-stage cascades from camera feeds, camera streams, in through YOLO Pro for object detection, tracking, and then directly to a VLM where we're able to do programmatic extraction of information. So this is a use case that you'll see a demo outside where we can do vehicle analysis for a customer like a Mr. Car Wash, for example, that wants to understand the cars coming in and out of car washes. We can tell the make, the model, the license plate number. Is there a roof rack? Did you choose the right washing option from our system? Or is it going to break, right? We can tell these things in an automated way. Was there damage? These are things you can't do with discrete computer vision models. Very difficult to train these models. We can do this one-shot, zero training, and build it into an industrial system. So this is super exciting. Try this out. We're going to be doing a lot more of this type of integration at Edge Impulse. And something that excites me a lot, we have Evgeny here. Jenny can raise his hand. We have Evgeny that owns a really exciting new initiative called AI Appliances at Qualcomm. And we've been working together with them because we've seen the AI appliance as a way that we can deploy more sophisticated workloads locally in industrial settings. We oftentimes get asked for this by big customers. And what this does is it packs up to 870 TOPS of NPU inference, not training, inference, into a single card. And today, Edge Impulse, we deploy to edge devices. This fall, we're going to be unlocking deployment directly to the AI appliance. So you'll be able to develop a model in Edge Impulse, deploy it to the AI appliance. So say you have brownfield devices that don't have enough compute power, an Arduino, for example, and you want to go do some more sophisticated compute, for example, Gen AI, you'll be able to develop that in Edge Impulse, deploy it to the AI appliance, and do that processing locally. And to give you an idea just how powerful this is, a single card can run up to 120 billion parameter GPT model, unquantized, with RAG. So remember earlier I talked about 40 billion parameters already being extremely high quality. This gets us internet scale LLM quality on the edge. So super exciting. And we're going further with this, right? Our customers often ask us, how can we deploy more of Edge Impulse at our site, right? At our industrial facility, right at the edge. We want to keep our data local. And we're answering now by deploying what they've wanted. So we're going to be deploying Edge Impulse on-prem on the AI appliance. That means you'll be able to get the entire Edge Impulse enterprise stack all deployed in a single box, all running at the edge. There we'll be able to do training, user management, data management, model deployment, model monitoring, and data collection all locally. Data never goes anywhere on the internet. This is super exciting. We're also going to do this in the cloud. So together with AWS, we're working to move not only data, which we already support hybrid cloud today, we're going to be moving all of our compute to the edge. So you'll be able to have us as the control plane, all the technology that's helping you develop, and we'll have the data and the compute staying in the customer's account, completely separated except for the control plane. So this is something to look out for, working together closely with AWS on this later this year. And with that, I want to invite a special guest on stage, Miller Cheng, President of EIoT at Advantech. Welcome, Miller.
Hi.
Welcome. Please take a seat.
Thank you.
So I figured Miller was a 9/11 type of guy. It turns out he is. That was a good
I hope
choice.
that next time I can drive the car to join the Imagine.
We can arrange that. So Miller's joining us because we have a really special announcement. We've worked with Advantech for many years. Advantech was actually one of Edge Impulse's first investors through an industrial VC called Momenta. So we have a long history of collaboration in this space. And we've seen this market mature to the point where we're ready to go to market together. So this fall, we'll be releasing Edge Impulse Enterprise built into Advantech products out of the box. And we'll be able to go and ship these products on a very wide range of cool Advantech products. You'll be able to buy a license, go deploy in the factory. We'll do that with visual inspection as well later. So really exciting new announcement.
Good. Yep, we are expecting that. I will show you later.
I want to ask you a few questions, Miller. I see a lot of applications, and today we're talking a lot about manufacturing. What are the applications that you're seeing from an Advantech point of view, where Edge AI is becoming a must-have?
Okay. Hi, Miller Zhang from Advantech, Taiwan. Actually, at Advantech, we are supporting the edge computing for diversified vertical market for more than 4 decades. In recent years, because of the high-performance AI technology are gradually introduced into the edge computing. So we're creating a so-called edge AI become a new standard in IoT industry. So as you can see, there are just a few cases in our service market. For example, like AMR robotics, healthcare, and also you can see like manufacturing and smart cities. I can give you some highlight. For example, like robotic and AMR market, the humanoid robot AMR solution in logistics and also the warehouse solution system They are saving labor costs, enhance the production productivity. Also, you can see the healthcare, the traditional medical imaging processing with the AI technology, they can enhance hundreds, thousands of times the efficiency.
So let's talk more about humanoid robots. I think this is kind of the holy grail of complexity in our space of AI. What are we missing to start to make humanoid robots developable with tools like ours?
Actually, the humanoid robot is a very big topic recent year. You can see from the report survey that more than 30% growth CAGR year over years. But however, if you look at the humanoid robot, you need to understand that not only the big brain for the humanoid, edge AI computing inside, this is the humanoid machine, their brain, right? And also you need to consider for the module integration. For example, like a vision sensor, like 2D, 3D camera, right? Wireless connectivity together, like 5G networking, or also the Bluetooth, and also the LiDAR IMU integration, motion control integration. And this is just the hardware integration. But most important also the software data training, right? Like you mentioned, for VLN and also LLM model training, how to train the data to make the humanoid, the machine, the big brain, more smarter, autonomous. That's very important and technology that we need to work together.
And that actually brings me that breadth of hardware that you need to build a robot, right? It's everything from connectivity to vision sensors to central processing, distributed processing. A lot of the audience doesn't know the entire Advantech roadmap, just how much you guys do. I'd like to hear more about like the breadth of products you have.
Let's start from our edge AI strategy. You can see this is we are co-working with all the mainstream silicon partner together to provide a very comprehensive hardware platform. You can see from the first line, this is edge AI embedded. I give you some example. The AI acceleration module plug into the existing edge computing. You can upgrade the AI computing power immediately without changing the system architecture. Also, the camera module that you introduced earlier, right? Also, the edge AI applies to many different diverse vertical market applications. Also, the edge AI server. But they are all the hardware. On top of the hardware solution, we need software value added. That's a very great example that we want to show our customer, our partner. Wait a second.
We have a new thing straight off the factory line from Taiwan.
This is
just in time.
This is the development kit that we create with Qualcomm Edge Impulse together. The development kit, for sure, there are some advantage. They have already the pre-verified Advantech devices with Qualcomm new QCS 6490, also the new IQ9, IQX solution altogether. Also pre-install, pre-verified Advantech hardware devices together with the pre-installed Edge Impulse tool for AI inference. More importantly is this exclusive 3 months the startup key for Edge Impulse built in together as a Edge AI development kit.
So you'll be able to buy a developer kit or a camera or a gateway and just get an Edge Impulse license pre-built. There you go.
Pre-built, yes, for sure.
Awesome.
And also very focused on some domain market, as you can see, like robotics, AMR, smart factory, or smart retail market. Very, very important development kit that can support our customer, also our partners, speed up your Edge AI development into your vertical market application.
Amazing, Miller. Thank you for joining us here at Imagine, all the way from Taiwan.
Thank you.
Great having you.
Thank you. Appreciate it.
And next, I want to dive deeper into the technology and invite Nakul Dugal, SVP and Group General Manager from Qualcomm. Welcome, Nakul. When we talk about car guys, Nakul is maybe the biggest car guy that I know. We'll talk a lot more about.
I'm not as big a car guy as you, but yeah, I do spend a lot of time with the automotive industry.
So everybody here, I'm sure, is dying to know more about why Qualcomm and Edge Impulse. What's your vision of how all this comes together?
Yeah, first of all, thank you for having me. I think it's incredible that you started this event in the middle of COVID, and you've sustained it for 5 years. I think that actually explains it. We've been a B2B company all of our, the last 40 plus years. We are now a 40-year-old company, and we've been very successful in bringing really edge technologies, edge products to pretty much every ecosystem. And that was kind of how the company was founded. But we were never really a developer-focused company. And so as we started to look at where the market is headed in terms of IoT and AI intersecting, it became pretty clear that for us to be able to continue on to this journey that we are on and scale our business, we would have to infuse very different DNA into the company. So as we started to look at how we would go about doing that, it was the companies we were looking at, but it was also the founders that we were looking at. It was also the types of culture and the types of mindset in terms of problem solving for the ecosystem, being more interested in the problem statement and then how to get to the solution. So that, I think, is what got us introduced. And I think it's been a great 12 months or so.
I 100,000% agree. And I want to dive a little bit more in the technology stack and how all this comes together, right? We're now talking about building Ferraris, right? So this is really complicated compared to what we do with microcontrollers.
Yeah. So I think for us, when we think about a stack, our stacks serve many different types of customers, right? Our stacks serve, maybe just to get started, we serve Android, we serve Windows, we serve Linux, we serve the entire mobile ecosystem. We are in PCs, we are now in cars, we are obviously in IoT. So it really is serving many different masters, and you have to start to think about the problem statement and then figure out how to internalize it from the perspective of what persona. I think you used the term persona earlier. What persona is interested in solving the problem? And then you have to meet that persona within their environment. You can't expect them to come to where you are at. So we've been going through this journey in terms of how do we build a very complicated Swiss knife that needs to have some very specific utility for the persona that you're trying to deal with. So we've been working with with Jan and with Zach and their teams, and of course the Qualcomm team, in terms of how to infuse that personality that we need to build around our products. And I think we've had, it's been a great journey. By the way, stay tuned. There is more to come on the developer side in the coming days. This ecosystem is a really important ecosystem for us. So you will see Qualcomm do more and more.
Yeah, and you can really think about that. This is building an open developer platform that works across the entire silicon industry. You see, we're keeping and expanding our industry that works on everything to bring this easy-to-use developer platform and make this cool new silicon technology. Like we've been talking about a few pieces of silicon like 6490 and IQ9. These are extremely complex mobile SoCs, almost unusable by a normal human being.
Yeah.
We're trying to expose these, right, to developers who just want to go and deploy workloads. And so that's kind of the holy grail of bringing all this together. We want to make this stuff easy to use.
I think one thing that has been really interesting, you touched upon IQ9 in your comments, this whole concept of cascading models, where it's a multi-staged workflow that is running at the edge. This wasn't something that people thought about 2 years ago, where the sensor detects what the camera is seeing or what the DSP is listening to. And then you kick off a chain of events that will be fed into, a VLM or a VLA. And today, if you think about how far along these systems are, at some level, image is actually become, fairly advanced. LLMs have become fairly advanced. Those are merging. But to be able to think about the problem statement at the edge and then simplify it and make it available for a developer to just use out of the box, that I think is still something that requires a lot of work. So we build tremendous products that actually have the ability to solve these problems out of the box. We just have to make sure that it's for the right persona.
let's talk about cars.
Yes.
So for those of you that don't know, Nakul built the automotive business at Qualcomm from nearly nothing to now a $45 billion pipeline. I was super impressed by the announcement together with BMW, the new BMW i3X, full ADAS stack, self-driving or assisted driving vehicle. Tell us about that journey building this level of edge AI solution for.
You know, the car is a really interesting platform because it is an edge platform. I mean, there is no other platform that is more complex than a car, and there are a lot of things that we think of in a car that we know as a consumer. And you were showing the video of measuring audio signatures, et cetera. What hasn't really happened in the history of automotive is so much of technology being directed towards this platform. And Tesla started this. You can start to see this now in China. But really, I think you have to think about the car as a first citizen when it comes to the adoption of literally edge AI, because everything in the car is real time. Everything in the car has a certain purpose because it is a product that is built for safety, for efficiency, for cost. It has to be something that you need to be able to use in a very predictable manner. And yet, if you think about it, there is almost no AI that is running in the car the way that you've been describing it. So we kind of caught onto this concept about 10 years ago, where we said it's super important for us to not think about the car as an adjacency, but it really has to be a foundational product segment. And we first started with the basics, quality, reliability, which obviously you have to be able to meet higher standards. But then we started to move towards the concept of safety-grade silicon. So every piece of building block that we build for the automotive industry is designed for safety, because you want to be able to run any kind of software without thinking about what surface area it's running on. As we took that approach, the auto industry realized, as a large semiconductor supplier and somebody who builds a lot of technology, Qualcomm will be a good partner. And so we became very interesting to the ecosystem. We started to think about ADAS quite deeply, because ADAS is the ultimate, and automated driving now is the ultimate problem statement when it comes to edge AI. It's real time, it's mission critical. You have to continuously be learning. We are all now users of this technology that seemed far-fetched not even 3 or 4 years ago. And so the partnership that we created with BMW was one where it was a leap for us, because we do silicon, we do software, we do a lot of IP, but we had never really done a stack. And for us, the complexity is, if you're going to do something, we have to go all in. We are not going to dip our toe in the water. And in this case, you can now buy the latest Neue Klasse BMW iX series with a Qualcomm stack driving ADAS running on Qualcomm silicon. So that's something that was a challenge that we gave to ourselves. At that time, we kicked off an entity from within a tier 1. We built our first automotive-grade silicon. We have over 1,000 people, 1,000 engineers working with BMW on a joint stack.
1,000.
Across 7 countries. We've collected 1 million kilometers of data. We have deployed in 60 countries this year. We'll be in 100 countries next year. So I kind of see the developer problem statement and this ADAS problem statement as opposite sides of a very complicated set of problems. But I think they are all kind of for the same purpose, where whatever we have to do at scale. So I think the automotive journey has been really eye-opening and very, very meaningful to this.
So let's talk about that other extreme. And I think there's a lot we can learn from building ADAS stacks. For example, robotics, right? How do we go and solve these problems? But then how do we make it accessible for developers?
Yeah.
When you and I first met, the first thing Nakul said was that, I want to get to 1 million developers fast. And I was like, I'm in. That's exactly my vision as well, right? Jan and I have always wanted to reach millions of developers. How do we think about this, like, developer vision and democratization? What's that going to do for edge AI as an industry?
I'm frankly learning the developer side. I'm not an expert. I'm very happy to be invited here and be amongst all of you. I think of it a couple of different ways. I think there is the technology aspect, which we talked about, which has to scale. There is an access to an ecosystem aspect that we are working on, that we will share with you soon as to how we are touching that. But then there is also a use case aspect. I think one thing, so we kicked off internally a program on humanoids recently. And what you realize on the humanoid problem statement is you have to run into yet another complexity of data collection and training, which is the action, where you are actually trying to mimic what a human does, because a car is actually simpler because you are, it's basically lateral movement and acceleration. That's all that you're really dealing with. But in this case, it's infinite possibilities. So we are working with companies that have asked us to look at a retail store, for example, and build a robot that will organize the inventory or the stock. Is the product expired? Has it fallen down? Is it organized per the kind of the design criteria for the shelf? And so it's a completely different problem statement because you're getting into kind of system on system two thinking. You have to be able to reason, you have to be able to act, you have to be able to go back and forth. So this is really endless in terms of the types of things that you have to go do. So it's this cycle of you have to have the right hardware, you have to know what is the speed at which it has to operate, what accuracy does it have to have, what training is needed, who are you going to get the data from, how these use cases are different one from the other, what's for lack of a better word, a 2D use case versus a 3D use case. But it's all part of that same spectrum of complex problems. So I'm super privileged to be part of this journey inside Qualcomm because we get to see a lot of complicated things and get to work with a lot of very smart people.
And our mission will be to make this all accessible for developers at scale. So that's the thing that you can expect to see much more of. Yeah. Nicole,
great.
Thank you for joining me.
Thank you for having me.
Thank you. So talking about developers, we've had amazing traction as a developer community, just Edge Impulse alone. Doubling year on year, we've gone from just over 100,000 developers now to 230,000 developers on the platform. And you look at our data collection, so this is the actual data that developers push onto the platform for training. We're at over 1 billion new samples just in the last 12 months. So this we expect to only increase. We're going to be putting a lot of new resources into developer programs, developer partnerships. We're going to hear more from Arduino next. And it's important that we go all the way back to the students in education. So we've just announced a complete new university program. We're empowering professors, their students, with all the compute power next year with new hardware so they can go and train all the engineers that someday are going to be working for your companies, are going to have your job. So all the young engineers learning about Edge AI and eventually powering this whole industry. So super exciting to see what happens with developers going forward. And with that, I just want to summarize. It's time to build Ferraris, guys. We've got the Fiat 500 down. We'll keep doing that. Let's build Ferraris together. Let's serve these high-end customers that we're getting access to now. And we got to do it as an ecosystem, right? Edge Impulse has a role to play. We're a developer platform. But we need everybody involved to go make these things happen. Every class of silicon, every class of OEM, ODM device, every type of system integration, everybody has a role. And let's get to that 1 million developers, right? We got a way to go. But this is the critical mass I think it takes. Once we hit this industry will just keep going and keep growing. So that's a goal for us all to hit. And with that, I want to thank you and welcome Fabio Ferrari Violante on stage.
Please welcome Arduino CEO Fabio Violante.
Hello. Hey, thank you very much, Zach. Thank you all for being here, and thank you, Zach, and the team for inviting me. Today I will take you through a little journey on Arduino and touch upon the human aspect, because these developers are humans, and the inventor of the future are humans. So I don't know how many of you are familiar with our history and how Arduino was born, but I can easily claim I'm not one of the co-founders of Arduino, as you can see there, but I am the grandfather of Arduino. So when I was finishing my PhD program back in 2001 at Politecnico di Milano, a technical university, I was studying human-computer interaction, so for safety-critical system, one of the most boring topics you can imagine in the world. So nuclear reactors and air traffic control, complex problem. But there was a funny initiative in Italy. So the school that you see there is called Interaction Design Institute of Ivrea. So a crazy lady decided to start a very innovative school in Ivrea, place where, for those of you that have like white hair, is the Olivetti town. So where they will be building personal computer, competing with IBM. And this was the ergonomy building where they were studying human-computer interaction back in the 40, 50 years ago. So this lady started the school, and they needed a professor of electronics. So I was coming from Politecnico. Politecnico is known for electronic engineers. They said, why don't you teach electronics to their students? But unfortunately, I had to tell to the dean of the school that I knew how to create on paper all the configuration of operation amplifiers, but I have never saw a chip in my life. So, but I introduced to the school the guy on top, Massimo Banzi, that was a close friend of mine, very eclectic person. He didn't have a degree in engineering, but he knew a lot about practical electronics and exactly what they needed, because he was really passionate about design. He was a real, very, very strong software engineer, and he was really patient, and he loved to teach stuff to people. So I introduced Massimo, they hired him, and basically he started working on project with students. The nice thing about this school is this was not an engineering school. The students in the school were psychology, cognitive psychologists, they were philosophers, they were creative people, designers. There were like 2 or 3 engineers. I think some of the co-founders, 2 of them, David Mellis, that now is product manager at Autodesk, and David Quartiers, they were actually students, and they were the 2 only engineers probably in the first class of the school. The problem they had was very simple. So every single project was one of a kind. So people coming up with, I don't know, interactive wallpaper, or any kind of projects, interactive lamps, everything required a custom PCB, and was probably not sustainable to wait for 3 months from the beginning of the project to getting a PCB ready from the factory. So they had to come with an idea. So Massimo said, okay, let me find a understandable microcontroller, the famous AVR that we use on the Arduino Uno, and we work around that. And the problem was not only hardware problem, it was also about software. How do we teach programming to people that never saw a line of code in their life? So they come up with the idea of creating this platform, and every one of the co-founders, there was no company, there was no Arduino, nothing. They came up with this idea of contributing to this project to make it easy for them to teach. So together, students and faculty started creating what became the Arduino Uno and the Arduino IDE. Basically, David Mellis wrote the IDE, and Massimo put together the hardware, making also some mistakes, because the connectors, this is a nice story. So the connectors you see on the Arduino Uno that made people crazy for the last 20 years were just a mistake, just put there. They were not compatible with the breadboard, so people still scream at us about that. But this made the platform very sticky, and every development tool you see in the world from silicon vendors, they have this format because it was not compatible with anything else. So this was like a mistake that became an important feature. So fast forward 7 years, this product went from by word of mouth, no advertisement, just people interested in the platform because it was open source, and that's an important factor. So David Quartiers said, why don't we do this open hardware and open source software? So that's basically a contribution, important contribution from David, and Tomaigo, the other co-founder, came with this idea that everything needs to be understandable. So he created the guideline on how to specify everything, avoid the engineering acronyms, and creating the library the way they are built today. So fast forward, they started selling, creating batches for the students, but then creating also product to sell on the market. And there was another guy in the co-founding team that was basically making this board. So they went from 50 units they were using in school to thousands, and then tens of thousands, and then up to 1 million devices. So at some point they decide, okay, we should do something with that. And they come up with the idea of incorporating a company, the company that became Arduino. And as all of you have been, probably many of you have been in startups, we are at the place of startups. One of the most challenging problems of startups is not technology, it's not engineering, it's finding a name for a product, for a company, etc. So they had a nice meeting where they were having an aperitivo in one of the bars in Ivrea, and they were excruciating meetings for the name of the company. So at some point, Massimo was fed up and said, okay, what is the name of the bar we are in? So it's called Arduino. Okay, let's call the company Arduino. So we'll stop the meeting. So basically, Arduino is the name of the bar where they were having this meeting. And so it's funny, but it's the reality. So, but the principle behind Arduino have rooted into very important historical things. So one of the biggest problems when radio and home appliances started to spread, and especially in Germany, like there was this brand called Braun, was training engineers. Guess what? It's the same issue we have today. So there was this designer, Dieter Rams, and you should go and look it up on Wikipedia, that basically created all the design for Braun, and he created also a very nice system to teach electronics to people that were just workers in the factories. Created a modular system that was a very important source of inspiration for Arduino. There was this Professor Erich von Hippel that was talking about democratization of technology and involving the user. This was another source of inspiration. And then there was Olivetti, the typewriters and computer manufacturer. It was a social, a very important social revolution revolving around good design and technology combined. So some of their products, they were a piece of art. So he involved high-end designers. All of these contributed to Arduino. Of course, fast forward, in 2015, Massimo called me and said, Fabio, I need your help because the company is growing. We have some issues that we have to resolve. Would you be available to join me? So I joined Arduino in 2015, and at that point, it was my expensive hobby. So I told my wife, oh, this thing is funny. I will work for pro bono for Massimo for a few days. And then days became weeks, and weeks, months, and years. So we resolved all the issue among shareholders. In 2017, I became CEO, and I started understanding how big was our community. And we have a sort of indistinct portfolio, so just treating companies and makers and educators the same way. So I said, okay, we should, first of all, understand who we talk to. So we created 3 product line specific for education, for makers, but a lot of, Zach talked about cars. So the first maker fair I attended here in the Bay Area, there was a guy from Nissan Renault, was the first people that came to our booth and said, oh, we use it for prototyping. We have a bunch of Arduino. I think I have about 2,000 Arduinos in my lab to do the cockpit prototyping. The second one was Audi. So basically, we were a sort of market leader of cockpit prototyping 10 years ago, and probably we are still for certain type of prototyping. So there was a professional market that we were serving without knowing that. So from there, we developed a lot. But before going into the products, what I would like to highlight is the sheer size of our community. So these are real numbers that we extracted from our system. Is 36.7 Arduino IDE download in the last 12 months, okay? And you see the geography there. So this is an impressive number, and it's growing all the time. So when I joined Arduino, we were in the 15 million. Now it's 37 million. This month is growing even more. So this is the 10th of September. We have more this year. So we had to do a lot of work. It's not for free because we had to renovate the IDE, create the IDE 2.0, etc. But from that IDE and that tiny board and the evolution of the portfolio, we enabled a lot of innovation. Drones started with Arduino, the open source drones. All the 3D, open source 3D printing. there were commercial 3D printers that were costing $60,000 each. So all these guys started new industries, billion industries with Arduino as a microcontroller. Healthcare application, ventilation, COVID, we mentioned COVID. Oxford University created a ventilator for developing countries based on the Arduino Nano platform. And it's countless. So basically in Silicon Valley, you can go and talk to anybody. They will have like 10, 15 Arduinos for each startup that has been created in Silicon Valley. So basically, I touched upon the pro part of Arduino, so serving customers that want to go to production. In this case, the revolution for us was really, really big because we had to do a lot of work. So we had 8-bit microcontroller when I joined, and customers now, it's 2025, needed more things. They wanted to run Edge Impulse to do models. So we had to create an entire portfolio of products. We classify this in smart sensing solution, where we have stamp size sensors, like this is a camera that we heavily use Edge Impulse and OpenMV on. We have industrial sums, we have automation solution, and the majority of the work has been on the software stack to enable more developers. So more development tool, the Arduino Cloud, and we worked a lot with integration. I don't know, Nakul, how you picked all your recent acquisition, but I was partnering with them before. So Edge Impulse, Foundries.io, OpenMV, they will have a speech here. So these are all our partners. So this is a crucial part of our strategy moving forward. And of course, evolving the knowledge base we have, because enterprise require more precise information. They require better libraries. So we have application libraries group that is developing robust and ruggedizing all the artifacts that they need. So this means basically creating a portfolio that goes up. So we are still in the 500 category here, and we are growing our portfolio. Now we have also a hybrid product with microcontrollers and microprocessor. There is more coming, so stay tuned. 7th of October, there is a final slide, but from there is a lot that is coming, more powerful, let's say, devices. But this is an AI/ML-ready portfolio that is available for you to use. Now, I would like to also ground this with a real story. So one of the biggest area where we see demand from customer is the area of anomaly detection. This is not just a paper stuff that you can see on let's say, presentations from vendors, but this is something real. So what we get asked by customers is normally the typical solution where you have an industrial machine and a need for predictive maintenance or for understanding early signals of malfunctioning, from stone crushing to the 2 examples that I will show here today, to Margherita that is also working with us on multiple projects. So a machine equipped with sensors. We have tiny sensors. We have multimodal sensors, microphone. We work with Sentient as well. We have cameras. We have vibration with Bosch Sensor Tech here in the Valley. So basically, you can create a machine network, normally radio or wired, and use the Arduino Cloud to do provisioning, to do all the data plane, but also integrated within our systems, there is Edge Impulse. So basically, you gather data from the platforms, train the models, and create a solution specialized for your system. This is a little detail about the use case that we will see in a minute. So Arduino Opta is our PLC. Think about an enclosed version of Arduino with a more powerful dual-core microcontroller and industrial interfaces for real applications. So we collect data, we feed this into Edge Impulse, do the analysis of the raw data, and then there is the training part with the Edge Impulse Studio, where people can do, depending on the case, but normally K-means, autoencoders, isolation, forests, so things that, of course, have nice names, but their complexity is hidden, fortunately, in the tool that make it simple for people to use. And the model, then this train model, becomes an Arduino library that you can compile in your code and push on the field using the Arduino over-the-air update feature. So the flow is this one. And this is not just me talking, because this is real. So you have also a lot of analytical tools. This is also a very important part, because signals are complex, and visualization is a good way to make the problem much simpler. And then deployment with the cloud, Arduino dashboards, so normal workflow, real application. So Atlas machine is one of the largest distributor of professional air compressors in the world, in the US. They have more than 5,000 customers. I didn't know anything about compressed air, but I discovered that compressed air is the fourth utility for industrial application, because everything runs with compressed air. If a compressor breaks, or a compressor farm, because they create like hundreds of compressors per customer, if something breaks there, the factory stops. So what they do, basically, they provide compressors, and they provide also maintenance services for those customers. And Atlas standardized on Arduino for automating the sensing and the anomaly detection for their compressor. So they went using Arduino Optas, our sensors, power meters. For the modern compressor, they use also measurement of electricity, profiles, and things like that, all integrated via the Opta Arduino system. But more importantly, they deploy algorithms that right now are talking to the Atlas people and just call the customer and say, you may have a problem on this machine. We are sending our technician to do support. But they're also evolving and creating a business model, trying to replicate their experience, so they are becoming a sort of service provider for this type of industrial customers based on our platforms, the Agyeman platform, and their expertise in this sector. And this is one case we are very proud. They are in Kentucky, very nice people. Go online, check them out on the Arduino website. So Richie became also a friend, but really interesting use case. Another problem, probably everyone is using bottles of everything, so from wine to milk to water. So capping bottles is a big issue, and there was Pack Expo last week in Las Vegas, and Italy is very big in this industry for packing and capping. So Arrow is one of the world leaders of this sector. So they have gigantic machine that can cap up to 200,000 bottles per hour. So gigantic machines, you know, filling and capping those bottles. The problem they have is these are, you know, high-speed rotating, multi-head rotating capping machines where a tiny vibration could be caused by poor quality of the material that is ingested. So think about capping 200,000 bottles and then having to rework them. So it is a nightmare. So you have to be fast in understanding what is going to go wrong. And this is basically what they did with wireless sensors, our tiny sensors, the Opta, and the edge impulse models to detect the anomaly there. So as a final remarks, of course, the world is really changing with software-defined everything. So that's very important to understand that we are in a different situation right now. What we think is that technology must be open, accessible, and human-centric. Human-centric is the key word for us because we work for humans. So the point is we are committed to not only supporting the AI future, but also to make everyone be part of this evolution. So as you saw when we started this conversation today, we were mentioning the students coming from different backgrounds. The new innovation will not come only from electrical engineers or from scientists and mathematicians, but can come from everywhere. So what is our mission is to keep enabling those people that can bring new ideas, lowering the barrier to entry with Gen AI, with models, with Edge Impulse, with our technology, and with our tools. So thank you very much. Just a final thing is stay tuned for October 7, 4 p.m. In Europe, 7 a.m., unfortunately, here. We will have interesting announcement. The campaign is called From Blink to Think. It's I originated this idea. So stay tuned with us, and thank you very much for listening to me today. And now I think there is a coffee break.
The show will resume in 5 minutes. Please take your seats in the auditorium.
Ladies and gentlemen, Imagine is resuming now. Please return to the auditorium and take your seats.
Please welcome Globalsense CEO Saeid Safavi.
Hello, everyone. I don't know why Zach made me angry here, but I'm not usually that angry. But my name is Saeid Safavi. I'm the CEO and co-founder of Globalsense. We are an edge AI company with a mission to bring what we call sound sensing or acoustic sensing into the automotive industry as a new complementary sensory mechanism. And today, I'm going to talk about how sound sensing opens a new dimension in vehicle fault diagnostic and predictive maintenance, saving time, money, and improving safety. Well, the truth is every car has a voice. The question is, can we understand their language? And let me tell you a little story about how sound sensing became our center of focus here. Over 4 years ago, I was speaking with a friend, a real car guy, and we were talking about how modern vehicles have thousands of sensors for tracking their health and monitors to, to track their situation, and cameras to also monitor their surrounding. And then something struck me. We as humans have ears for a reason. So why don't cars have ears? Why can't they listen for faults like some technicians do, or hear events that matter for safety and security? So that question puzzled me for some time. I started looking around, looking at papers, publications, conferences, podcasts, name it. And I found almost nothing. So I said, well, maybe we'll do it ourselves. And as Franz Kafka once said, if it's not written, write it yourself. And 4 years on, after a long and challenging journey, I have the privilege to introduce you to our latest acoustic platform product. And basically, that will be the center of my focus of my talk today. Having said that, actually, that same friend, this journey started 4 years ago, as I said. That same friend is now part of our team in this mission. So going back to earlier days, we started focusing on security and safety events. So we were looking at events like car crash detection, car braking, window glass break, and events like that. And as a matter of fact, one of our customers today is mass producing this technology in their aftermarket tracking devices being sold worldwide. I will introduce that product in my next slide, but want to emphasize that the center of focus of presentation today is on vehicle maintenance. So that's the product I was talking about, which is an aftermarket tracking device for the very first time enhanced with an built-in on-device AI using our technology. The name of company is Positioning Universal. They're a well-established company building hundreds of thousands of these sensors, these trackers annually. So basically, what we did with them is integrate our hardware using Sentient chip with a very minimum bill of material so that it really didn't affect the overall price of the device as such. And this market is part of a $35 billion global market that is addressing, GPS basically tracking and collision detection. This technology usually use IMUs or accelerometers to detect crashes. Yet, almost up to 30% of collisions are missed through the accelerometer solution. And there are different reasons for it. For example, usually the technology fails to detect more complex crashes like side swipes or rollovers. And sometimes this could be fatal accidents. So our sound-based AI basically filled in this gap by, and this is a real critical gap, by detecting the actual sound of the impact and other, crash sound related, like, for example, tire screeching noise before the crash actually happens. And by doing that, we also listen to security events, as I mentioned, car braking or glass break, So all of this results in a product that has more accuracy in terms of event detection, fewer false alarms, and more services, leading to a better user experience. Okay, this, as I mentioned, the center of my talk would be on our newest device, which is called Autosonics. Here is a 1-minute video to introduce.
Tired of the guesswork? When a car has a problem, you need answers fast. But what happens when even the best mechanics are stumped? Introducing Autosonics, powered by Globalsense, the simple solution to complex problems. It's the new tool that takes the frustration out of diagnostics. Forget complicated equipment. Autosonics, powered by Globalsense, uses advanced technology to instantly pinpoint issues, so you can fix the problem right away. With Auto AI Diagnostics, Autosonics listens to your car's sounds and detects engine and transmission issues instantly. Our AI is lightweight, flexible, and runs anywhere: mobile, PC, or cloud. Device, app, and portal, working together to turn sound into intelligence. That's Autosonic. It's the one tool that makes all the difference.
All right. So the fact is some major components of a car, like engine, transmission, or accessories, faults can only be detected through their sound. The problem is diagnosing cars with sound is difficult because the technician or person who, like inspector who checks the car, cannot, first of all, listen the sound from its source. It's usually contaminated with other sounds of the car or also environmental noise to start with. And then there are other parameters like time pressure, they need to finish the inspection in time, and also difference of experience make it even harder. And there's a paradox. The more experienced the technician is, then their hearing is usually weaker. And that's a real practical problem in this industry. But this leads to costly consequences. For example, auto auctions today lose millions of dollars annually in arbitration fees. And on the other hand, dealerships suffer from costly trading adjustments and also weaker, basically a lot of cost for repair labor that is wasted because of bad diagnostics. But the good news is, as the cars speak, every fault has an acoustic signature, kind of like a fingerprint in noise. The problem is humans cannot reliably pick it out. So this is where AI changes the game. AI listens with consistency, precision, and scale. It doesn't get distracted or lose hearing over time. It's actually exactly the opposite, because the more data it gets more and more powerful. So that's the opportunity to basically unlock a vehicle sound and turn it into actionable insight. To give you a better sense of how acoustic sensing is working in action, think of it like going to a doctor's office. A physician listens to patient heart or lungs, and that gives them a general sense of the patient well-being. But if there's something subtle or hidden, they need an MRI. They need a CAT scan to see what's really going on. And that's the same thing with vehicles. For example, in an auction setup, the technician who listens to the car for an engine fault can only detect 50 to 60% of faults. And this is based on our statistical data gathered over many measurements. While our model today is 90% plus accurate, because it sees the hidden patterns that exist in the acoustic signature where our ears miss. So Basically, to give you a better sense of how it's working, I'm going to play for you a short sound clip of a vehicle with a fault buried in the noise of the vehicle. So it's difficult to hear it by listening to it, because humans listen to superposition of all the frequencies, not one at a time. But then I'll also play for you the AI extracted sound of that very same fault, that same vehicle, and you can hear the difference. And now the AI sounds good. So that little ticking noise is actually one of the major problems of engine. It's very costly to repair, but it's very difficult to hear it first time. So to conclude, this is not about substituting human, if you like, expertise, but rather, augmenting with a deeper view, same way like modern medicine does with advanced imaging. From our end user perspective, Autosonics platform consists of three major components: device, app, and portal, seamlessly connected together to convert sound into intelligence. Our process starts with data collection phase, wherein the Autosonics device collect high-fidelity audio, and sometimes coupled with live OBD data. OBD means the onboard diagnostics, that all the cars have an interface for it. And then the data goes to the mobile app, and over there, we do data prep and fusion. And from there, the data travels to the cloud, where it undergoes labeling. Labeling could be automatic, could be manual. The label data, in turn, fed into the AI training pipeline, and then the trained model would power the inference engines that could live in the cloud or directly on the mobile app. And for this, in this system, we have a very powerful front end and back end in collaboration with our partners like Condition Nose software, Mimic microservices, Edge Impulse platform, and AWS backend. Okay, to show you the actual real-world impact for the auto auction use case, we put Autosonics into test in pilot studies across 12 different locations in US and Canada. Each pilot study ran for 3 to 6 months, and it is long enough time for you to gather meaningful information so that you have information about different cars at different regimes and vehicle conditions to give more diversified, if you like, test scenario. 2 AI models were tested, and the results were very consistent. Autosonic delivered accuracy margins of 30 to 40% over human inspector. And the diagram on the right basically shows what it means in practice. It's a diagram that shows the saving you can make with Autosonics for this specific use case as a function of the number of inspected cars that the auction does per month. As you can see, for a decent auction size, usually, average, they do 15 to 16,000 cars a month. The saving quickly adds up to $1 million per month. And that's where I call AI starts to turn sound into real financial value. In terms of our vision is to extend this technology into embedded acoustic sensors for OEMs and tier 1 suppliers as a complementary sensory mechanism to many other sensors they have. And these could be like low-cost sensors that can be installed in different locations in the car and can detect anomalies or early faults through sound. and also can trigger more complex AI running at the edge. For example, our mobile app on a cell phone, or the app on an infotainment system dashboard of the car. The goal is to alert the end user about early problems before they escalate to something bigger, because you hear the sound from its source, even a tiny one, and you can extract it, even if it's in other noises by AI. And that could definitely be, in support of predictive maintenance using this technology. Other use cases, for example, for OEMs, is to use it in their software-defined vehicle, SDV platform, to prevent recalls by early detection of problematic components. It can even be used in production quality control as a mechanism to measure some anomalies during production. And of course, it can be added for other safety, security use cases inside the cockpit, outside the car, etc. All right, so this was the first part of my presentation, but I have a few slides to discuss our integration with Edge Impulse by focusing on the tool chain. Yes, that's the real work. Focusing on the tool chain, automated data pipelines, and custom blocks. So as you know, any AI system, one of the very first and important steps is data prep. And our data wasn't always clean. We had, some recordings were just simply bad. There were recordings that were, again, the noise were buried in, the fault were buried in noise, or there were like multi-fault samples. Only about 20% of it were kind of easy to label. So for us to be able to do label, because here the labeling is very critical, and it's a very expert thing. It's not like listening to a glass break. You need to know exactly what you're labeling. We created a set of automated tools to address different aspects of the challenges that we were facing in terms of, for example, data prep, data segmentation, augmentation, and also accuracy checks. In terms of the Edge Impulse features, we found a lot of the features there very valuable to us. Things like multi-impulse, data explorer, pipeline, expert mode, custom blocks helped us with data prep and also model optimization, ensuring consistency, also detecting outliers, helping us importing data, and also build our own custom models and integrate it seamlessly into the workflow of the Edge Impulse. But being an AI company focused on sound, we also have developed our own internal tool set to analyze and prepare data in more sort of sound-centric fashion. Things like different flavors of sound augmentation, data set separation and classification, and some form of sorting and filtering. I don't get to the details of this because of time, but I would like to thank the Edge Impulse team and also our team at Globalsense to build really a very robust tool set for automation and building product quality models in a fraction of usual time. And at this point, I would like to ask my colleague, our AI head, Dr. Alejandro Moran, to join me on the stage. He flew all the way from Spain to help me with the next few slides.
Thank you.
So I think, Alejandro, you've done a great work on these parts, but in interest of time, I'll go to the next slide and would ask you to discuss a little bit about what we do today for auto segmentation and auto labeling.
Yes, thank you. So I would like to go a little bit more in depth on how we are using the Edge Impulse platform in combination with our custom blocks. So we began with manual segmentation and labeling with the help of expert knowledge to classify this kind of audio, and in order to have a strong, robust AI model at the beginning. Now we transition to automated segmentation and labeling. we are implementing this as custom blocks within the H-Impulse platform, and our own data coming directly from the recording devices. As an example, I would like to show you a clip here for specifically for the segmentation part of it.
So this segmentation is done in real time on your platform for 36 or 38 second data clip or a song.
But this is only an example, only one of the steps. I would also like to show the whole pipeline here. So we start with the raw data from stored in S3. We have different files like file 0, 1, which we segment with the automatic segmentation block in segments that are meaningful to us, while filtering silence and noise. So for instance, here is 0, is 1, is 2, etc. Then we take each of these segments and assign meaningful classes related to car faults, or so that we assign to the audio, to each segment of the audio, if the car is healthy or has a transmission fault or engine fault, different kinds of specific faults. By the end of this process, we have a curated data set which we can import into existing or a new H-Impulse project and follow the training, evaluation, and deployment steps, closing the loop, and ending with a methodology which is consistent, which is reproducible and scalable. Well, that's basically it. With this methodology, we are transitioning from the manual segmentation and labeling bottleneck into a much more faster pipeline running in the cloud to accelerate the way to on-device artificial intelligence for our use case.
Yeah, and that concludes our presentation. I would invite everyone to join our demo table. We have a booth there on the other side. That is a very cool demo. We show all the process from data collection, the mobile app, all the way to upload it to cloud and the AI model analysis. So we'd be happy to discuss it in more detail with you guys. Thank you.
Thank you.
Please welcome Hydrostasis founder and CEO, Debbie Chen.
Zach, I didn't get a car. What happened to my car? Okay, just to be awesome, can everyone just have a little sip of water? I know we just had a coffee break, but more water is good. Hi, everyone. My name is Debbie Chen. I am the founder and CEO of Hydrostasis. We build hydration monitoring wearables. I'm wearing, this one is our Gen 1 right now. I'll talk about our Gen 2 coming up. And of course, we are a customer of Edge Impulse, so shout out to the team. And I'll talk about our work with the Edge Impulse team in just a bit. As we're building for hydration, we realized that we're building all these great tools, right? We're talking about all the tools and the agents and all of these things, and yet our tools are only as good as the data that it's trained on, right? So this is what I'm talking about, is the data equity and how we can address them as we build. So how many people are wearing wearables right now? Yeah, rings, smartwatches, right? We got all of them. So wearable devices can actually be life-saving for vulnerable populations, right? Or folks that can't get to their hospitals, places where it's not accessible. But also harmful biases are actually embedded within our wearables. But if we think about wearables as equity tools, we can actually build for such an amazing impact in a lot of different ways. This one study in 2024 actually shows that there's 5,000 wearable systems deployed across 22 countries, everywhere from the neonates all the way to geriatrics, right? So this is really, really impactful work. But again, our tools are only as good as the data sets that they're built on. So let's talk about technical biases. After COVID, we had a lot of issues with pulse oximetry. There's a lot of studies, and this one included, that showed that pulse oximetry is actually less accurate for folks with darker skin. So unfortunately, Black patients showed that they had 3 times more frequency of hypoxemia than compared to white patients. And this caused a lot of patients to be sent home, right, and when they really needed to be in the hospital. Sleep monitoring. We all love our sleep. We all love tracking our sleep. But what about cultural differences where families sleep in one big bed, right? Or, for example, if you have shift work, right? Are these models accounting for differences in our sleep patterns? And what about the one-size-fits-all designs? Accessibility, affordability, disability. In fact, one of the reasons why we chose this strap versus a normal watch strap is because we were targeting older adults, and there's dexterity issues. So let's think about these technical biases and make them better. Did you know that women were not allowed in clinical trials until 1993? It's pretty absurd, right? So think about all of the treatments, all of the pharmaceuticals, all of the processes that were established before 1993, right? There were no data from women, unfortunately. And women are usually typically cast as smaller men, right? So this crash test dummy is 4'11" and 108 pounds. And then even the male is based on 1970s. Somebody decided this male is the average male, right? ADHD diagnoses are a lot different for girls and women. And so what happens is that females are less diagnosed, and then the symptoms are vastly different. Pain management protocols for women, especially, endometriosis actually takes about 7 to 10 years to diagnose, right? That's insane. Productivity, we were just talking about temperatures in office buildings, right? This was built based on a 145-pound man, 40-year-old man wearing a business suit, 68 to 72 degrees. What happens is a lot of women are really cold in the office buildings, right? So again, let's think about why we set our temperatures at these temperatures and who are we serving. So we built better tools. Now we have great tools, amazing tools. Again, what are these tools using for data sets? It's really hard to read, so I'll go through this. But in this one study in 24 in the Lancet, they actually did prompts using clinical diagnostics, right? So 25 prompts for every single one of these indications. What ended up happening was that, unsurprisingly, GPT-4 overestimates numerous health conditions in Black patients versus white patients. Things like hypertension, HIV, multiple myeloma, prostate cancer, type 2 diabetes, and colon cancer. And again, unsurprisingly, GPT-4 underestimates conditions in women compared to men. Things like COVID-19, pneumonia, tuberculosis, hepatitis B, endocarditis, et cetera. Some of these are over 50%, right, underestimates. So again, let's think about the data sets that our tools are trained on. A couple things. Let's address these things, right? Think about inclusive design. Who are you building for? And actually, who is on your team? So one of the examples I'd like to mention is that for those of you that are Tesla owners, who do you think the folks are that the doors don't work? You have to stick your fingers in the doors, right? Folks with acrylic nails. It pops off their nails, right? Okay, niche market, and maybe if you're not targeting those folks, that's fine. But again, I guarantee you there was nobody with acrylic nails on the design team or the testing team, right? They would have noticed. R&D reform, what kind of data collection protocols are you using? Participant recruitment methods, and where are you recruiting from? Data governance, right? This is a big topic. California just passed SB 53 to protect whistleblowers and things like that. So we're on our way. But the regulatory folks are moving a little slower than our developers, right? So think about data equity, security, usability. Is this data set actually appropriate for what you're trying to do? Or are you scraping the internet for whatever you need, right? All right, so shifting gears a little bit to what I'm doing at Hydrostasis. I believe hydration is the missing vital sign. And the reason why is because if you think about all of these really great biometrics that we have, on our hands and in our rings and everywhere else in our ears, you kind of know what's good and bad, right? Heart rate, SpO2, respiratory rate, but we actually don't know that about hydration. So why is hydration essential? Well, improper hydration impairs everyday function. Heart health, muscle health, kidney health, brain function, overall human performance. But the problem is that if you have improper hydration, it actually increases the risk of hospitalization. We have about 10 million seniors that are hospitalized for dehydration every year. And it comes with a 20% increase risk of death. This is all preventable, by the way. Currently, our clinical hydration tests are severely outdated. So you have pinching the skin, which is very measurable. And then unfortunately, as we age, we also, the skin test doesn't work very well. You have tracking weights. So folks with heart failure or kidney disease are sent home to step on a scale. Well, that works sort of. But what are you wearing? What time of day? Did you just eat a big meal, right? It's hard to tell. And what kind of scale are you using? And then there's also swollen ankles and sunken eyes, and basically the doctor's best guess. So this is the state of the art, right? So we went out to solve that. So this is actually our Gen 1 product, the Gecko Watch. And we proved a couple things. We launched in 2024. We proved a couple things. One is that we sold out, so people really wanted this. Secondly is that we wanted to test our value props, right? So what kind of customer insights are we looking for? And the first thing is a real-time indicator. How hydrated am I right now? So we put it into 3 buckets: hydrated, mildly dehydrated, and dry. And then we also said, what do I need to know? Well, one thing I need to know is if I'm ready to do the next thing, right? I could be well hydrated right now, I could be in the blue, but if I'm gonna go for a run or something like that, do I need to hydrate more to stay in the blue? Right, so we put in real-time notifications as well. So we spent this last year learning about our customers, and we realized that simplicity is key. We're inundated with all this data, right? All we really need to know is if we're hydrated or not. I'm standing up here talking about data equity, and you think, oh, my data is very well balanced and amazing, right? Not so true. So we did okay with the female to male ratio. But then when we were looking at age, older adults don't really want to participate as much as younger adults. We were trying really hard to get a nice distribution on the weights and BMIs, because also current wearables don't work well for folks with higher BMI as well. And then, of course, we cared about skin tone, so we used the Monk scale from 1 to 10. And you can also see that my graph ends at 7. So we tried, and we try for better data sets, but again, it is difficult. So even with the effort that we put in, it is challenging. But it's worth it. Super excited to talk about our next launch. This is the Gecko Watch 2.0, where we've completely redesigned it with a sleeker look. We have our advanced algorithms. We moved the calibration to the background, so it's a smoother user experience. We added 2 new sensors for heat and physical exhaustion. And then for our heavy sweaters, we also added water resistance. And of course, the most important thing is our on-edge algorithm. And so shout out to the Edge Impulse team again. So we actually have an algorithm deployed on the Edge Impulse platform that we're currently testing for Gen 2. So why did we decide to do on Edge, right? The cloud works just fine, right? Well, it actually opens up a whole bunch of different markets for us. The markets such as the military for data security and privacy, industrial workers, policemen, firefighters, folks that don't always have their phones with them or are constantly connected to the cloud. So we're excited about this, both on the technology side, of course, and also on the business side as well. Okay, so phones out, QR code is here. This is our website. Sign up for our wait list. These are actually pictures of our Gen 2 that came off of the production line last week. Super excited. My team is actually testing it right now. And so, yeah, really excited to show this off. So the one that you saw earlier and on my hand here is Gen 1, and this is Gen 2. So we're soft launching this year with a larger launch in Q1 next year. Okay, lessons learned. Number 1, data infrastructure is important, obviously. You guys all know this. My example is that we had a whole bunch of different studies, right? We're trying to collect the data, and we had a bunch of different studies, and we had inconsistent data storage. Some data sets have different metrics, other data sets were stored in different ways, and so that actually made a big headache for our team. So think about the data infrastructure and also, future data collection. Number 2, product features versus model performance. This is sort of the bane of all of these companies, right? Like you have your product team and your marketing team telling you want to do this, and then you have like the engineers that are trying to build the thing, right? So one example was that we moved to intermittent data, which is great. Clear product win because it extended battery life. Okay, well that was difficult for our data team because that meant that the data sets and the batches were inconsistent. And then also we had to aggregate for a longer time, right? So the lesson learned is that you got to have your product team and your modeling team really talk about these trade-offs. And you can't have one or the other just making those decisions because the other side will kind of get mad. Lesson number 3, build model observability. And we all know this. But one of the examples is that we had this really great model, and it looked like it worked really well. And you use your accuracy and your recall and all of your metrics, right? But when we dug deep and then we looked at the predictions, it ended up being that this model, by and large, predicted one category, right? And so failures in the real world, such as like temperature variations, power variations, model compression, right? All of these impact your model on edge. And so building tools and obviously logging and things like that to observe every step of the way is important. And number 4, edge-first data processing. Most people start off cloud and then move to the edge, right? But as we know, everything is on edge. So if you're bringing new products, think about edge-first data processing and how is that different? Because it actually might be the difference between a viable and a non-viable product. Think about processing data, pipelines. Think about memory usage, battery life, incremental streaming data versus batch data, right? All of this ends up being impactful for your edge-first product. Don't worry if you're not taking any notes. It's all on this blog that just got published, I think yesterday. So I just wanted to shout out to Dr. Michelle Hugenhout, who is our lead data scientist that's working on this with the Edge Impulse team. She's not here today, but this is all of her work. Okay, so questions to ask before you build, right? What is your mission? Who are you serving? And who are you building for, right? Who are your customers? Who's on your team? All of this is important because it goes into your mission and your why. And if we think about this stuff and we build our tools and our data sets, thinking through these things before we build, we can actually create better tools and more equitable data sets for all of us. Thank you.
Please welcome IDEO Managing Director, Emerging Technology, Savannah Kunovsky, and Edge Impulse's Director of Applied Research and Edge AI, Daniel Situnayake.
They didn't introduce.
Hey, everybody. It's cool to be back at Imagine. An amazing last talk. That data equity piece is so important. I'm Dan. Some of you might know me. I lead the research team at Edge Impulse, and I've been around since the start of the company. I've been doing Edge AI stuff for quite a while, starting at Google, working on TensorFlow Lite, joined Edge Impulse right at the start, written a couple of books along the way. But I'm really excited to be able to invite my friend here on stage with me to Imagine. So Savannah, you've done some amazing stuff. You've set up programming schools across Africa. You've worked on AI relationship therapists. And right now you're managing director at the Emerging Tech Lab at IDEO. And I'd love to hear a little bit about like what that means and what you guys do on your team.
Yeah, happy to. Maybe before I talk about myself, to show, not tell what we'll be exploring, I can do a little bit of an exercise with you all. It's going to be kind of weird. Is that OK? It's OK? Enthusiastic, yes? OK.
I'm going to do it, too. I have no idea what we're about
Beautiful.
to do. So.
I'm going to do a magic trick. Just kidding. Close your eyes. You are about to go to the moon. You look down at your hands. There's space gloves. You look around. There's all sorts of metal and knobs and dials that are ready to take you up there. On the count of 3, you're going to blast off. And you're going to go up through the atmosphere, around the moon, and then come back down. And you'll have about 30 seconds. Ready? 3, 2, 1. Blast off. Up through the atmosphere, around the moon. If you haven't started to, start to make your way back down to the ground. And open your eyes when you get back to this room. Okay, so we did this exercise because so much of the time when we do that type of things with kids, they shoot off to the moon before I say go. They go all the way to Mars. They take their friends with them, and they just completely don't follow the rules. But when we do this with adults, they follow the rules for the most part. You know, you go up, you're in your spacesuit, and you go around the moon. And I think that this is illustrative of, you know, the title of this conference is Imagine, right? It's illustrative of the need for more creativity and the need for more different types of dimensionality of the creativity that we're bringing to the work that we're doing. Because we have all this training and all this knowledge, which is great for creating all of the products and services and companies that we all build, sometimes that makes us lose some of the edge of creativity that we have when we're younger or just a little bit more open-minded. So really what the purpose of design is to help us imagine new possibilities, help us to see new futures and new potentials for the things that we're designing, the organizations we're creating, the experiences that we're creating. And that's the work that I do at IDEO across a huge spectrum of different forms of technology.
Fantastic. Well, thank you for that. That's really cool. I definitely feel a bit more spacey than before.
Oops.
So I wanted Imagine to have a session where we kind of explore the implications of this technology we all work with on our future. So kind of going beyond what we can do today and what we've been doing in the past. I think some of the stuff we're working on can have a pretty profound implication on the way that people live, the way that people work. And it's not something we spend enough time talking about, I think. So that was my goal here. So Savannah, I think you've said in a past talk recently that we live in the future already. And I'd love to touch on that. I happen to agree with that, but what makes you say that?
Yeah. I think that we live in the future and we just kind of haven't recognized it. It doesn't look exactly like the Jetsons space age future, but we have cars that drive themselves. We have people getting brain chips like implanted into their brains. Controlling Mario Kart and playing video games through a chip implanted in your brain is an amazing feat of technology. We have self-driving cars. Even phones, you've had a tiny computer in your pocket for almost 2 decades that has more compute than the first space missions. Like, it's a really amazing and remarkable thing how much technology we have and how prolific it is. And really, when we take a step back and we kind of look at all of that stuff, it is really futuristic technology. And I think that right now, we're in this place where, because we have all of this pouring in of investment into various forms of AI and other forms of technology, we get to make a choice about the type of future that we want to build and the type of future that we want to live in. And I think a lot of that, yes, comes from the R&D and kind of how we build things, but also really from how all of these products and services get designed and delivered to people.
And so in the last few years, there's obviously been this explosion in AI. And when we talk about AI, it's mostly been chatbots, really, outside of this kind of world. And I think the idea of embodied AI and physical AI is just starting to come back into the conversation in a bigger way. Why do you think that has been neglected until recently, and why are we only now hearing about these big advances in edge AI?
Yeah, I think that a lot of the time when we have new technologies that start to become more popular, it's because there have been technological breakthroughs, either in the technology itself or in the manufacturing of the technology on one side, and then also because there just starts to be more demand for better experiences. And I think that what's happening is we've kind of reached some of the thresholds and limitations of what the last chapter of technology could offer us. And now that we have all of these new and interesting capabilities that are being unlocked through these technological breakthroughs, it's time to shift those and design those into more actionable things that people are able to use in ways that really will change their lives.
So you agree that we're kind of on the cusp of a whole new set of ways of interacting with computers. Are there some tangible examples of those that you might want to share?
I thought you'd never ask. Yeah, so I've been doing a lot of work in the last couple of years around everyday robotics and new forms of personal devices. And I like to bring this pet. I'm not going to call it a device. This is a pet. It's a robot pet. It's called a Mothman. His name is Cabbage, with a K. Named by one of our good friends at work. But the reason why I bring him is because, again, show not tell what I think that the future of technology might look like. I think the last era of robotics and many of the everyday devices that we use have been very functional feeling and very industrial feeling, which is great for the purposes that those serve. But when we start to think about bringing robots into people's homes or just by things that would kind of live alongside us, they need to have different form factors that actually integrate well into our homes and integrate into our lives, both from aesthetic perspectives and then also from the perspective of what is it that people like will trust more? And this thing, if I take the fur off, it just looks like a hunk of plastic and metal and electronics. But when you cover it in fur, okay, let's take off your human suit. Yeah, but when you cover it in fur, then immediately becomes lovable, which is not a word that people often use to describe robots. And so I think like the next era of home robotics and home devices that will be really popular are going to be things that are designed in a way that really resonate with people, whether it's that we have home robots that rather than looking like big, scary machines, they just look like your air purifier and other kind of devices that you already have in your home, and or if it's that we make things that are cuter that people want to take care of as soon as they see or get totally freaked out by, depending on who you are. But yeah.
Yeah, and I think there's this element there of like we've now got the technology to do this type of thing without needing a big bulky device that's made of heavy metal and needs to plug into the mains. All of the stuff that we've been working on the software side with algorithms for perception, on the hardware side for more and more efficient processors means that we can build these new form factors that weren't feasible before.
Totally. Golden age.
So in a recent talk that you gave for InfoQ, which is really, really good if anyone wants to check that out, you asked, what if AI was so useful that it faded into the backgrounds of our lives, was there when we needed it, and wasn't the centerpiece of our existence? And so that sounds like a great vision of the future for me. Are there any other examples of like what that might look like when you think about that? And what kind of opportunities are there for the Edge AI community to help?
Definitely. I think there's huge opportunity for all of you. And there's been a movement in the design space for quite some time called the calm technology movement. And that's in contrast to the devices that we all see and know today that are built for your attention and built to take your attention. And instead, what if we had devices that kind of faded it more into the backgrounds of our lives? So, if you had, there's a beautiful provocation by a designer, I think Max Braun, that is a portrait that you put on your wall, and then it just shows you in very like faint, dark lettering the like headlines of the day. And so you can have your news that's delivered rather than through flashing headlines and ads and all of these things that are kind of causing us as humans to have an emotional reaction. You can have kind of a more calm experience that's faded into the background. I think there's the Samsung Portrait TV also, which does a really beautiful job of that. Having software that's more, and hardware that's more embedded into like the mirror in your bedroom and kind of can give you different feedback about like if you're doing makeup or about aesthetic things. What if like the doorways in our homes, when you walked through them, they could give you information about your biology and could help you be healthier. So what if the future of technology wasn't this thing where we have these crazy looking robots kind of wandering around our homes, but instead our homes still felt like places of calm and of peace, and they just had really useful technology that was embedded in the places that it makes sense for it to be embedded.
I think there's this like growing understanding now that there's something bad about being on our phones, scrolling all the time, literally doing it during this talk. But I think there's this opportunity to kind of break that connection between like a computer type thing or a phone and technology. Like we can have all these capabilities without being glued to a screen. It's almost like a cliche to talk about screens, but it's like, it's such a thing that we can't get away from it now. Even like this little guy comes with an app.
Yeah.
So you've also discussed the idea of mutualism with regards to technology. So I'd love to touch on that and kind of explore a little bit like what that is, and is that something that we are at yet, or is it more of like an aspirational idea?
Yeah, I think that it's sort of an aspirational idea, but the basic idea behind mutualism is it's a concept from biology. And in symbiosis, which maybe we remember from like middle school biology class, there are different types of relationships that organisms can have between each other. So symbiosis, I think the way that we kind of know it is like you have two organisms and they both like benefit from the relationship between them. That's actually a subset of symbiosis called mutualism. There's parasitism and other forms of symbiosis as well. But in mutualism, you have two organisms that are able to kind of feed into each other and both benefit from the relationship that they have. I don't think that's necessarily the relationship that we have with our technology right now. And I think that it's going to become a more important concept as technology becomes more advanced and it kind of has its own sets of like needs and desires. And if we want more from it, then we're going to have to give to it in ways that it is going to be able to grow and flourish from as well. And we created this vision of mutualism kind of in reaction to a lot of the sci-fi visions that we see about the future of technology that feels super dystopic. And so, you know, what if we created like self-healing computers that, you know, benefited from getting our data, but also we could support them in growing through giving them like new materials to work with. I think that there are some organizations in places that we're seeing this that are more outside of the tech ecosystem so far, but if we can, rather than have this vision that is feeling really like harsh and negative about dystopic robot futures, if we can take inspiration from like sci-fi authors like Becky Chambers, who talks about a future of robots where we both kind of like get to know each other as the species that we are and then figure out how to collaborate and coordinate, that feels much better to me.
Absolutely. So in one of the conversations we had before this session, we were talking about the topic of designing for trust. And I think that seems very fundamental to this whole thing. So like, why is that important and what does it mean and how can people start to think about it?
Yeah. I think just in general, like the TLDR on that is that if we're going to ask people and try to sell people more technology that's going to be smarter and more embedded into their lives, then we have to design technology that people trust. And I think that is a major opportunity for Edge, because if people are able to like own and know where their data is and not have to feel like they are going to be taken advantage of or that it's going to be sent to places that they don't trust, then they'll be less likely to buy our services. We already know that if you label your product that you're selling as AI, then people are less likely to buy it. And it's because of all of this kind of nervousness that people have about how that might work and how that might affect them and what it is. And you know, people that are deeper into the tech ecosystem are kind of like, great, amazing new technology. Of course, I want to like put this everywhere and do everything that I want with it. But that's not the reality of how people receive these technologies that we're creating. And so designing products and services that people really trust and they feel like they want to have around them, they want to have in their homes is incredibly important.
Oh, yeah, that's so powerful. I think that's a really good note to end our session on. So I believe we have lunch next. But I'd like to thank Savannah so much for coming on today and sharing some of her thoughts.
Thanks for having me.
Please enjoy a lunch break. The event will resume at 1:30 p.m.
take my smile to your pocket. You got me, you and I'm losing to you, I'm a sinner. Time, taking my mind, I'll never see you in the dark, 'cause you're shining bright. Why you leaving me now? I'll never see your soul inside, but I tried so hard. So many mistakes, crashing my system. Gave me some different places to hide. I've never wished you stay this night with me. I only knew I want you by my side. Taking my mind, I'll never see you in the dark, 'cause you're shining bright. Why you leaving me now? I'll never see your soul inside, but I tried so hard. Why now? 'Cause I why now? 'Cause I so many mistakes, crashing my system. Gave me some different places to hide. I've never wished you stay this night with me. I only knew I want you by my side. I'm searching for perfect shelter for you and me. Everybody think that I'm off still, but I want to feel. Time, taking my mind, I'll never see you in the dark, 'cause you're shining bright. Why you leaving me now? I'll never see your soul inside, but I tried so hard. My demons in the my smile to your pocket. You got me, you and I'm losing to you, I'm a sinner. Time, taking my mind, I'll never see you in the dark, 'cause you're shining bright. Why you leaving me now? I'll never see your soul inside, but I tried so hard. So many mistakes, crashing my system. Gave me some different places to hide. I've never wished you stay this night with me. I only knew I want you by my side. Time taking my mind, I'll never see you in the dark, 'cause you're shining bright. Why you leaving me now? I'll never see your soul inside, but I tried so hard. Why now? 'Cause I so many mistakes, crashing my system. Gave me some different places to hide. I've never wished you stay this night with me. I only knew I want you by my side. I'm searching for perfect shelter for you and me. Everybody think that I'm off still, but I want to feel. Time taking my mind, I'll never see you in the dark, 'cause you're shining bright. Why you leaving me now? I'll never see your soul inside, but I tried so hard. my smile to your pocket. You got me, you and I'm losing to you, I'm a sinner. Time, taking my mind, I'll never see you in the dark, 'cause you're shining bright. Why you leaving me now? I'll never see your soul inside, but I tried so hard. So many mistakes, crashing my system. Gave me some different places to hide. I've never wished you'd stay this night with me. I only knew I want you by my side. Taking my mind, I'll never see you in the dark, 'cause you're shining bright. Why you leaving me now? I'll never see your soul inside, but I tried so hard. Why now? 'Cause I know. Why now? 'Cause I know. So many mistakes, crashing my system. Gave me some different places to hide. I've never wished you'd stay this night with me. I only knew I want you by my side. I'm searching for perfect shelter for you and me. Everybody think that I'm off still, but I want to feel. Time, taking my mind, I'll never see you in the dark, 'cause you're shining bright. Why you leaving me now? I'll never see your soul inside, but I tried so hard. My demons in the cloud shades, run away from monsters. I told them they were safe from the monster that I felt.
The sessions will resume in 5 minutes. Please take your seats in the auditorium. The sessions will resume in 5 minutes. Please take your seats in the auditorium.
Ladies and gentlemen, Imagine now resumes. Please make your way to the auditorium and take your seats.
Please welcome OpenMV CEO Kwabena Agyeman.
Howdy. Hi, everybody. I'm Kwabena, president and co-founder of OpenMV. And today I'm here to talk about our new cameras, the OpenMV N6 and AE3, which are going to change the game for what folks are going to be able to do with edge impulse and AI on the edge. Using that word too much now. Anyway, so first, what is OpenMV? We're an open source computer vision project that was founded in 2015, so 10 years ago, actually. I've been doing this for a long time and keeping the dream alive. When we started, if you Googled computer vision on microcontrollers, all that you found on the internet was a Stack Overflow article that said that that was impossible. You couldn't do computer vision on microcontrollers. Since then, when we started, we were working on the Cortex M4 architecture. That was the highest end thing available. And over the years, we've seen a radical growth in the processing power of these systems to the point that we are literally thousands of times faster over these 10 years than we were at. Anyway, so over these 10 years, I worked at OpenMV as a side hustle for 8 years, had a day job, kind of kept it alive through that. And then 2 years ago, in 2023, I went full-time trying to grow the company. We're fully bootstrapped, funded through 3 successful Kickstarters, and we've done about $350,000 through our Kickstarters combined for funding the company. Additionally, over these 10 years, we've sold over 100,000 OpenMV cams into the world, either through direct sales or licensing through our partner companies like Arduino. Over 10,000 unique customers. We actually hired someone to do some BD analysis of our email CRM on our Shopify website, and saw a huge amount of different folks have been buying our products, lots of different verticals. And since we started, we've done about 4.5 million in revenue lifetime. Anyway, so this year, we're closing in on making about a 1 million in revenue. And since I came back to run the company full-time and take it out of side hustle mode, we've been growing at 75% year over year. And we're super excited for next year because we'll actually have new AI-enabled cameras that we can bring to the market. It's been a long journey, but things are about to change for what we're able to do in the world and what we're able to bring out here. So one, how have we been able to bootstrap this company and build this hardware and put it out in the world? What's our use case? What's allowed us to be something that people actually want to use? It comes down to we've been kind of solving a tension between power consumption, price, and performance. So for a lot of applications, when you want to start scaling out the hardware, it becomes really expensive to build the infrastructure for a system. Let's consider a task called automated gauge reading. This is something that we've always been approached over the years to do. And now we're actually finding deployment of our system with large commercial industrial customers who are using our cameras to read legacy gauges in a facility. For them, what we're able to offer is a system that is priced in a few $100s and is able to run on batteries for years. This means that they don't have to pay for the infrastructure cost of running conduit and new cabling and wires to basically update these legacy gauges in their industrial site. Having this kind of functionality and being able to cheaply scale and deploy into a large system allows folks to build out this technology, go slowly, but then scale up quickly with a copy and paste type of model. Additionally, what we're finding now is that people really love this solution when they can bring the analytics on device. So for that automated gauge reading, it's not just that we're sending pictures to the internet and having that all run on the cloud, but we actually look at the gauges, use computer vision on board to reduce what the picture of that gauge is, and actually send the numeric value to the cloud. This allows the OpenMV cam to really be the one-stop-shop solution for these customers to build out an application. And so what has made us win in these, as I mentioned, for these kind of applications is having real-time AI or machine vision on device, the ability to operate on a battery, be wireless so that we can be deployed in these large industrial infrastructure projects, and also that we're affordable in cost of a few $100s. So that's where we were at. That's what we've been doing, and that's what has allowed me to bootstrap this company, survive, and not be on ramen noodles. But I'm excited for the future. There's a massive jump in performance from where we were at last year and where the industry was at and what we're going to be transitioning to now. And just to give some numbers to this, so our previous high-end microcontroller was a RT1062 at 600 megahertz. And the maximum performance of this processor was about 1.2 gigaops. And so this meant that if you tried to run a YOLO V5 model, for example, you would get the amazing frame rate of about 0.4 FPS. Super awesome for doing real-time AI on the edge. And that would give you about 0.8 watts of power consumption. It's technically workable. You could do some demo applications with that. But it's really not going to blow people away. It's not going to be something that folks actually want to use and start building a product chain out of. And so when we now are moving to new AI-enabled microcontrollers with neural processing units on board, things have changed greatly. All of a sudden now we're at 204 billion operations per second. And then also we're moving up from, instead of having about 1 megabyte of RAM on chip, which is not quite enough to store the outputs of a model and do inference and everything else you need, now we have chips coming on the market of 13 megabytes. All of this combined, we're able to take that same YOLO V5 network, and that goes from 0.4 frames a second to 28 FPS. Now it's real time, now it's running at about 30 frames, but also power consumption has fallen. We're going from 0.8 watts to 0.25. For our OpenMV Cam AE3 that I'll talk about in a second, we only draw 50 milliamperes in operation when running YOLO V5 or YOLO V8 or et cetera. What this means, we're at a 200x better situation. And this has big implications for what you're going to be able to do with AI on the edge. So here's the future. You're going to be able to run YOLO at 30 FPS for less than 1 watt of power. And with a microcontroller, you're going to be able to go to deep sleep modes on demand, wake up from them on demand, and you're going to be at about 1 milliwatt of power or less. This means it's going to be easy to put AI in everything, all kinds of nonsense. So do you want AI in your toaster oven to check to see if that Hot Pocket you're baking at 2 a.m. in the morning and make sure it doesn't burn? Sure, let's do it. Do you want to put AI in your microwave to look at pizza that you're cooking up? We can make that happen. Do you want to put AI in a blender? I don't even know what that would be for, but let's make it happen. So this is the future. It's become cheap. With that kind of power and performance scale, it's now possible to bring smartphone vision algorithms to all sorts of nonsense devices. And this is going to open up a huge aperture for your creativity and what we can build AI into and what we can make better. So I'd like to introduce to you guys, we have 2 new cameras that we built our technology stack for. The first one powered by Aleph Semiconductor's Ensemble E3 processor is the OpenMV Cam AE3. And so Zach was showing this off earlier today. This is our smallest OpenMV Cam. We designed it to be 1 inch by 1 inch. And we're packing all sorts of great stuff on there. We've got a camera, 1 megapixel, Wi-Fi, Bluetooth, time of flight distance sensor from ST, accelerometer, microphone, pretty much 5 sensors in 1 inch. Super powerful computer, useful for adding AI and automation to whatever you'd want. And then also, we're supporting ST's behemoth, the new STM32N6, which also offers similar kinds of functionality, a high-resolution camera, Wi-Fi, Bluetooth on board, an AI accelerator that's about 3 times faster than Aleph, and also high-speed USB, gigabit Ethernet, and many other pieces of functionality, bringing it closely in comparison with a Linux SBC, actually. The benefit of both these systems, though, are that they are microcontrollers. So this means you can power them off instantly, power them on instantly, survive on batteries for years. So what are some of our customers building? What are people doing with these things? We've been super excited to see the kind of adoption from folks being interested in this. I live in Soma. It's a challenging neighborhood in SF. And to the culture of that, I've been doing drug deal level sales of our cameras. So we've had founders coming into my house, and I send them a PO on the spot for thousands of dollars, and they leave with little cameras and baggies. It's been incredible, the adoption and the interest that we've seen for this camera technology. Folks definitely want it. We've been selling out of prototypes as we've been building these things. I even had one customer who was so desperate for these cameras, they ordered a small production run of a previous generation prototype. Not even the final rev. They wanted it so badly, they were asking us to build prototypes and take those to production for them that had issues. This is how much there's this demand for these cameras. And so let's share a little bit about two customers who are using these products. First, we're happy to announce that we have the customer Invictus Security. They actually supported our Kickstarter for these new cameras big time and really helped us get over the 100K mark when we were getting just started in our Kickstarter earlier this year. And what they're doing is they're using multiple OpenMV Cam N6s for a remote connected security box. This device, putting two cameras inside an IP67 rated box, long-range wireless comms with high-power IR LEDs. So this box will trigger a PIR motion sensor, wake up the OpenMV Cam N6s from not even sleep mode, just deep power off, so totally disconnected, and run YOLO V8 on board and capture motion, will capture a picture of whatever it sees from the motion detector when it triggers, and then wirelessly communicate that back to a base station, not only triggering on a person being detected via YOLO V8, but sending JPEG snapshots, high resolution, back to the base station here. What made us successful with Invictus Security for their new platform is, one, we're able to offer actually quality camera sensors on board. So with the N6, we're able to handle 5 megapixel HDR sensors. These have the ability to actually see outdoors in the direct sunlight, so they're not blinded by cell phone cameras of yesterday. And then with that, we have the hardware on board now, modern microcontrollers, to do things like H.264 video compression if we wanted to capture a small video clip, but also image JPEG compression so that we can capture a high-resolution image and transmit that back easily. Better yet, we're actually able to run real YOLO models of significant resolutions on board these systems. So a YOLO V8 416 by 416 model, we're able to get 15 FPS or so aboard the N6 here. That's decent enough to do real application work with. In fact, we have another customer who's using the system, and they're actually pushing it to 512 by 512 pixels, and we're still able to get about 7 FPS with 80 class output. This is starting to mirror what you can kind of do with an NVIDIA Jetson-based system, albeit much less frame rate, but still the usefulness of being able to capture a picture to figure out what's going on and running a actual AI model that people will want to build a product with. It's here for MCUs. And then finally, best of all, we're able to offer a 1.6 second power off to inference result detection speed. So this means the N6s can be totally powered down, not a single amp of current to them. And with the PIR motion detector, once that triggers, there we go. Snap my fingers, within 1.6 seconds, we have detected and triggered, found a person in the field of view after booting the camera up, and transmitted that result. This makes it possible to really build a connected security product such as this that is going to operate in a remote region, basically powered by a lead-acid battery with no solar panel and last for years, and still be able to provide excellent performance. But even better, we're getting all sorts of applications that don't even fall within the camera space. So one of our partner companies, well, not a partner company, but a customer, Sarama, they are here, actually at the conference today, Parful, over there in the back. And they found our system through, he listened to a podcast I did earlier this year called Embedded FM, and was super motivated by how we were trying to think beyond the current place and time for microcontrollers today. How we can bring more functionality on board to the edge. And so they're building a system that listens, something that can translate your dog barks. And it was crazy to me because they're not even using our camera, the thing we specialize our product on. Instead, the value we brought was having a platform that has an AI accelerator on board, a microphone and a gyroscope in one tight package, so they could focus on their application and not focus on designing crazy hardware and trying to bring up the latest microcontrollers. What they're super excited about is being able to take models from the cloud and putting that on board these devices. Since we can now run smartphone AI models on these chips, it means they no longer have to run the same level of data infrastructure that they would have had if they were dependent on older generation MCUs. So no need to store hours of audio on board, no need to have that giant security hole in your system software where you could theoretically have recorded everyone's conversation on your dog. Those are problems that you may not want to build into your product at scale. So anyway, what made Sarma successful for using our product? Why are they interested in that? As I mentioned, everything's on board, including Wi-Fi and Bluetooth. These are features that really tie everything together. And additionally, as I mentioned, staying compliant with security laws. But then having megabytes of RAM on chip really makes the difference. What's exciting about these new modern AI microcontrollers is the huge amount of integrated RAM on board these systems. Being able to buffer all your audio data for seconds without having to page that in and out to save that to flash, being able to do large amounts of analytics on board. These things are new supercomputers, really able to do so much more. And then finally, having ultimately a ridiculous battery life. Being able to go from, for example, our previous OpenMV cams were always around the 130 milliampere power range at 5 volts, being able to bring that down to 50, or even in their case, 20, it really changes the game for what you can do for all-day battery life. So, what will you build? We're excited about where things are changing in the AI and IoT realm. This tech is here. As I was saying in this talk, these cameras, the OpenMV AE3 and N6, we're going to be bringing these to market in December. We've been working on hardware revs all year and getting all the bugs out. We're excited what people are going to be able to do. You have all the sensors on board you need, a microphone, accelerometer, camera, and even time of flight. We also support thermal cameras, event cameras. All of these new modalities can be combined. So it's time to build multimodal AI. It's time to make things that are smarter. Let's leverage these MPUs and build the next generation of connected IoT equipment. And also, let's imagine what you can do with Edge Impulse. Thank you.
Please welcome our moderator, the new Stack's founder and publisher, Alex Williams, and panelists, IDT CEO, Margherita Ferragatta, Ampere Computing's chief evangelist, Sean Varley, and Canonical's head of software partnerships, Aniket Pongshe.
Out on the big stage now. So excited. Hi, everyone. I'm Alex Williams, founder and publisher of The New Stack. We're a media publication. We focus on at-scale development, deployment, and management through really explaining stuff and analyzing stuff as best we can. And our audience are software engineers and developers, so I feel right at home here today. And so why don't we have you all introduce yourselves. Margherita?
Yeah, thank you, Alex. Hi, everybody. I'm Margherita. I'm CEO at IDT. IDT is a tech company that was founded in Turin with the idea of bringing open source hardware and software solutions in the world of industrial automation. So we were born as system integrators. Let's say that the world of industrial manufacturing has always been filled by proprietary technologies, full of licenses and royalties. So what we're trying to do is to do something different. So whenever it's possible, we try to make our clients avoid what is called the vendor lock-in, let's say. So that's why we're long-standing Arduino partners, as Fabio told you before. And yeah, so we started out mainly in the automotive industry. So we end-of-line solutions and continuous improvement projects, as you'll see afterwards.
Aniket.
Hi, I'm Aniket Pongshe. I run our software partnerships here at Canonical in the Americas. A lot of you will have heard of Ubuntu. Canonical is the company behind Ubuntu. We are super developer focused with a huge ecosystem of folks who run Ubuntu today, whether it's on the cloud all the way to edge and IoT. We have tailored products for each of those verticals that you see there. And then I think most importantly for this, we are sort of the de facto operating system for AI everywhere. And a lot of AI is open source. So we like to think it starts with us.
Way to go. Sean.
Yeah, thanks, Alex. Sean Varley, I'm the Chief Evangelist for Ampere Computing. Ampere Computing is about a 7-year-old company, 8-year-old company, and we focus on sustainable compute and more specifically AI compute, which means that we build processors that are probably orders of magnitude more powerful than what you just saw on the stage previously. But that's kind of all fitting into a much larger ecosystem where AI now is changing the way all things are done in computing. And so what you see here is our kind of product lines from 32 cores all the way up to 192 cores. So really server class, but also now being pushed to the edge, and we'll talk more about that.
Well, great. Well, one of the real interesting aspects of Edge AI today is the overall ecosystem. I think that's really the best context for us today. And I was thinking about this a little bit before the conference, and thinking about it as a hardware layer, the operating system layer, the platform software layer, and the application layer. And Sean, when I heard Zach Shelby talking this morning, I really thought about this question in relation to what you do over at Ampere. And he talked a lot about how in 2017, TinyML started, but it was like all these tools that were available for machine learning were just really not appropriate for edge environments. Can you take us back to that time for you and Ampere, and how those technical hurdles have lowered and what that means for use cases today?
Yeah, absolutely. It's a really good question because, what you got, if you go back in time to really the early roots of ML, it was really kind of constrained by compute in a lot of ways. And so, models were much smaller than they are today. And what you see is that as computing was kind of growing, and you heard Kwabena, I hope I didn't get your name wrong, talking about NPUs in small packages. All of that compute getting kind of integrated into large scale, VLSI type of ASICs and standard, kind of products has changed the entire game, right? So now you can do things like YOLO in a very small device, but you can also do a large language model with over 1 trillion parameters in CPUs and GPUs and other accelerators. So that kind of progression from 2017 to now, present day, it's not been that much time, right? So all of the open source and the frameworks and everything else had to change along with that. I have a very distinct impression of how the hardware's changed, but everything in the chain that you mentioned has had to change along with that.
And so, Aniket, I recall Ubuntu being really at the forefront of Edge AI, or Edge environments, back in the, dating back to even the 2014, 2015 with Ubuntu Core. By 2017, we started seeing new lightweight Kubernetes distributions emerge. And that really, I think, helped position Ubuntu, didn't it? To be able to establish itself with Ubuntu Core moving forward. And I know that you just had some recent announcements, as of last year. I'm curious on that time frame for you and what you saw emerge, as you were getting Ubuntu Core into a state of better maturity.
Right. So I think Sean touched upon this, and you also mentioned there's foundational problems when you think of Edge AI that are different from AI in the cloud or AI on your normal desktop stack, right? One is the people, the set of embedded developers who were brought up with Yocto or kind of roll your own Linux is distinct from people who are cloud native and are running on Kubernetes and TensorFlow and PyTorch and all of that, right? That's one. The second is the stacks themselves can be different. So when you look at the software that's being deployed versus what you're training on, that's going to be somewhat different. And then security is a third thing that comes in, where now the default expectation that enterprises have is increasingly that the same level of security which was applied to the cloud and the data center is now available at the edge. And our kind of story is, you can use Ubuntu on the cloud and you can use Ubuntu on the edge. What that's going to let you do is accelerate your development to deployment cycles by far. So you're talking weeks, not quarters. When you think of new models coming in, very rapidly you can reach that time to market, time to value. And that goes up the stack. Like we have deep integrations with things like Kubeflow, MLflow. So we can actually run an entire open source cloud for your training and then deploy it at the edge with things like Kserve.
So we've heard a little bit about the hardware environments, the operating system environments. I'm going to put the framework environments on hold a little bit and go straight to application layer for Margherita. And the discussion about Arduino this morning really opened up my eyes to kind of where you were all at the time. And you were telling me beforehand that this was kind of an interesting time for you back in 2017 or so when your company was just getting started.
Yeah, it exactly happened like the same thing to us, but like at the application layer. So when we started out using Arduino technologies, like we wanted to use open source technologies, but it was back in 2016, 2017. We actually met with some Arduino guys on the train. It's how our partnership started. But their solutions were not industrial ready. Like, let's just think that Arduino Pro, the business line, was born in 2020. So yes, it was quite difficult for us at the beginning to start because we wanted to use open technologies, but not many hardware open technologies were ready for the industry. So we had to do lots of partnerships and we had to do lots of developments and integrations. And then Arduino came out with some industrial ready solutions. So yeah, that's how we started. That's how our story happened, and I think one of the biggest successes was that then in 2022, I think, we managed with their solutions to carry out what you're seeing on the screen. This is a pick-and-place application of handling the battery cells of hybrid cars of a big Italian luxury automotive company, let's say. Like Zach hasn't said anything before. And so yes, in this case, you can see two Kuma robots on the screen, and everything is handled by two pieces of Arduino hardware, and even acting as cross-link, one with the other, to handle the communication between the robots. So yes, I think that's our greatest achievement.
That's really interesting. And Sean, when we think about the specialized chips today, and what they provide, how are they impacting use cases now? How are you seeing that?
Yeah, we're really in a gold rush of sorts, right? You see AI creeping into every aspect of life, going from hyperscale data centers all the way into the edge, through the networks, right? Through the distribution networks. Previously, you probably saw up on the screen some of the telco changes that are happening because telcos are starting to leverage their position in proximity to users, right? To start to put forth infrastructure that can then process AI. But that's also going all the way out to the edge. So here you see intelligent video, kind of recording platforms also changing. In fact, the OpenMV, that you just saw earlier in the previous presentation is very similar, right? It's just that the AI is happening at the camera, but there's a lot of aggregation, and AI can happen in layers. It happens in the device. It happens as a backup in the cloud or at the edge of the cloud, and all the way back up into hyperscale data centers. So all these use cases are kind of blending, but also have their own unique segments. But I think what's really interesting about this is the level of integration of different technologies, because in everything that you do with AI, it comes with a power penalty or cost, right? And so you hear a lot today about, the data centers needing small form factor nuclear reactors and things like this, right? But that same paradigm is happening at the device layer, right? You're trying to fit things into small form factors, right? On batteries. All that stuff is changing radically the silicon that's being designed to be put in those devices, but also, what type of optimizations can we create through the application layers, the OS layers, the size of containers and things like that. The size of the model itself has a huge, huge impact on the actual footprint of the hardware.
So Aniket, when you're thinking about these new emerging use cases, what are some of the trade-offs that you're starting to see? What are some of the forward-looking thinking that you're having to consider when you're thinking about, well, you know, the market's not quite ready for this, but there are these use cases that are evolving, that are still not quite mature. How do you kind of consider those trade-offs yourselves?
In terms of, everything's changing, right? Like the technology is moving so fast with the models evolving every month, every quarter. As I mentioned earlier, security is a key dimension that comes along. Chips are getting faster every year. What that is enabling is a whole bunch of new use cases that were really hard to implement or impossible to implement before, which can lead to real business outcomes. So I think on the slide I have many. I'll pick Asina to start with. Asina is the brand behind Ann Taylor, for those who shop for clothes in the US. They use our open source ML stack to implement a real-time recommendation system that can give customers choices at the point of sale. And they actually had measurable business outcomes of 10% more cost of sale once they actually implemented the solutions that can let you go to market faster. Similarly, we had Duke Energy and others in that space do real-time load balancing of, when your windmill is generating electricity, it's not doing so at the same rate every minute. So as soon as the wind stops, you have to load balance and say, oh my God, I need more power from this other network. All of that's real time, all of that's AI. These are things that you couldn't easily do even 3-5 years ago that people are starting to put into production in the coming time frames. I could go on, but.
Right. We've talked again about the hardware layer. We've talked about the OS layer and the application layer. Perhaps you could talk a little bit as well, just a follow-up question to what you're saying about models, with these frameworks. We're talking about millions of developers that we're trying to get to start using edge environments. I think 1 million what is the initial goal. I'm curious on, what kind of models can now be deployed, and what kind of use cases are they allowing across different hardware configurations?
Is that to
either one of you? Yeah.
I could take a crack at it. So coming back to where I kind of ended that last set of comments, so the size of a model makes a huge difference on where you can run it, right? So if you're running a really large size parameter model, maybe hundreds of billions of parameters and things like this, then you can't fit that into a small scale processor like we were just looking at. You have to fit that into a GPU, or in many cases multiple GPUs, to be able to run that kind of a model. And let's forget a trillion parameter model. This is kind of large scale, rack scale, kind of computational horsepower needed. So the framework that you're going to use to be able to deploy these models matters a lot, because the framework now has to not only just compute the model, but it has to be optimized to run on a specific chip, right, or a specific architecture within that chip. And those things require intelligence, right? So what you see happening is this level of intelligence is starting to kind of hone in on a size of a model that's most appropriate for the specific use case, but then also optimizing for the chipset that it can land on. And all of that intelligence is filtering all the way up through the frameworks and into the orchestration layers.
To add to what Sean said, Kwabena talked to it earlier as well. Like, you were talking of tens of thousands of point-of-sale systems in the past. Today, you're looking at millions and millions of sensors out there that are all sending you back the data. And it's becoming important that you right-size your AI story. So does your data have to necessarily go to an expensive cloud, adding latency, adding cost? Or can you actually process it close to where it's being produced and send the analytics back up to a larger scale system? So right size.
When we're talking then about automotive environments and talking about where you're seeing the industry today, are they ready for edge AI? Is it all they're talking about in the automotive industry? Kind of what is the state of things in the automotive world?
So it's quite hard still. So when we started out, it was hard to implement open technologies, and now it's still hard. I mean, sometimes people change the tech specs, but still they do that only when they want to have like some trade-offs, when they see that, okay, I cannot have everything that I had in the past, or like, okay, I can also try something new. And as Aniket said before, I think one of the main reasons why this happens is the time to market. So very often, like new solutions, open solutions, or like Edge AI offers, like an Edge Impulse solutions offer like a lower time to market. So that's something like that the client starts reasoning about. The second thing why they might choose to try like Edge AI probably I think is the fact that there are so many latencies if you only rely on connectivity on clouds, on servers, especially in industrial plants, in the manufacturing. Like it even happened to us once that the client didn't allow us to use their Wi-Fi connection or their Ethernet ports. So in this case, like you're stuck. If you don't have some offline functionality that can guarantee continuity to the production, you're stuck, because as we were talking about yesterday, even like reaction times in a production environment and in the automotive even more like need to be deterministic. So they cannot just be left like, and sometimes it's really a matter of milliseconds. So the more you have in terms also of offline functionality and communication with the PLC and everything, I think the more the better. And yeah.
So Aniket, I want to go back to you, and then we'll go to Sean with some few last questions. Then we'll conclude with Margherita. But can you talk to me about what you're seeing as what is attracting developers to edge environments? What are some of the trends that you're seeing with the developer community, and how, what is like bringing them to think about edge more in their work?
Right. I think one of the big changes that our partnerships with the silicon makers have caused is standardization of a platform that is setting the stage for you to focus on your application development rather than worry about, oh, does my OS boot, right? So we have a full supply chain story with Advantech as an example, Thundercom's another one, where your time to actually start working on your story has reduced a lot, and developers really appreciate that. They get the same cloud-like environment that they're used to with the Ubuntu, but it's optimized for the features of the silicon that they're running on, which is a fantastic story. The same set of applications, Kubeflow comes to mind, Keras comes to mind, TensorFlow, all of those which were natively running on Ubuntu, guess what? They're now available to you at the edge. And that causes this explosion of new ideas, of new products that you can actually build in a much faster timeline that makes it economically viable to do that. And all of that's backed by the same 10-year LTS guarantee that Ubuntu comes with.
And Sean, a lot of this gets very complex at the hardware layer. You have to think about a lot of different factors. I mean, the amount of engineering that's being required. Maybe you could provide us some insights into how you're thinking about the overall infrastructure of these edge environments in terms of the storage capabilities, the in-memory capabilities, the networking capabilities, and where are we now? And what are you seeing coming next?
Yeah, I actually made a prediction at a conference earlier this year. Most in the past, computing was measured by some kind of esoteric performance benchmark, that you had to sort of be insider to understand and stuff like that. But my prediction is that all compute in the next several years will start getting measured by power. How much power does it consume? And it's going to be able to process AI, right? So because AI has such a power tax, you will start to see processing classes be built according to how much power they consume. And so you'll see these really micro power watt, watt devices, and then you'll see large scale, hefty rack scale modular architectures. And all of those things will come with their associated power tax. But how that kind of translates, I think, to what you're asking is that, people that consume them will also be looking at a number of other parameters that are important to their use case. If I'm processing vision, you saw frame rates, right? You saw resolutions, you saw things like that. In LLMs, you might have a situation where you're looking at, okay, how many languages do I need to recognize, through spoken word? All these different parameters will kind of, again, dictate the size and configuration of those models. And then those models will start to be able to be processed by a certain amount of power, right? And so all of that will kind of, I think, naturally gravitate to create markets, right? And I think that's one of the biggest things I think we'll see simplify the complexity of all of these different layers that are kind of in AI now.
Yeah, and so downstream then at the OS layer and the distro level, how does that impact how you think about, the workloads that users will be wanting when they, see what's coming available, on these specialized hardware environments?
Right. It's a very good question. I think to your point of power, there's different form factors that are somebody's going to sip power, somebody's going to gulp it when you're training really high power stuff on NVIDIA DGXs, for example. We offer different ways to reduce the footprint of your base container and your application itself. So if you're on the cloud, we offer a technology called Chisel, all open source, by the way. You can go play with it. To reduce a deployment, I think one of the examples was with Microsoft.NET, where the container went down from 200 MB to 50 MB. So that's a significant reduction in everything. Boot up times, power consumption. Security is much better because you're securing a much smaller footprint now. On IoT, you have Ubuntu Core, where it's security first containerized app, kind of like your phone app, but for your IoT device. And that's much smaller than what a traditional Ubuntu would be. And we have some other stuff coming for devices that are even smaller, which would be very exciting to this audience, but can't talk about yet.
So that gets to my question for you, Margherita.
Okay.
And you work with these automobile companies, and I expect they're a pretty ambitious group of people. So what are you hearing from them about what they really want? And how does that impact, like, for instance, your application wish list, so to speak?
So first, let's talk about what they want. And what they want, I think, is to have flexibility and to really use operators to give to their products added value, because there are so many operations that are carried out that don't bring added value to the product. So I think that a real shift where AI comes in and everything we talked about comes in is the shift from Industry 4.0 to Industry 5.0, where flexibility is at the center, there is a human centricity, and AI can really help the operators in the lines. And then if I have to talk about my wish list, obviously, our company mission is we update standards thinking out of the box. So obviously, my wish list starts with the idea of not having to struggle to bring open technologies and edge AI in industrial automation and in industrial manufacturing. But having the clients believe that these solutions are actually reliable and they can guarantee product continuity.
Okay, so we have a little bit of time left. So Sean, Aniket, I'm going to ask for your wish list based upon what you're hearing from customers. What would you think they would be wishing for at this moment, which they would see so they could take on this next generation of use cases? Sean?
Well, everybody wants a lot of horsepower in as little power, actual electricity as it can get. But the state of the industry is such that we actually try to rise to meet these occasions, right? And so what you see happening is that a lot of us are stretching to put kind of capabilities into smaller and smaller packages. And in our case, in Simon Semiconductors, our packages are measured in centimeters or millimeters. And so the industry is kind of starting to rally around this idea of being able to take and mix and match functionalities. Right? We like to call it heterogeneous computing, something that does a little bit of AI acceleration, a little bit of general purpose processing, maybe some sensor, some communications. You mentioned storage earlier. All these things are going to be combined into more and more complex SoCs going forward. And I think one of the things to kind of draw it back to our hosts is that the platforms, right, the frameworks that can actually translate that to developers, as Edge Impulse does, is a super, super powerful combination.
Yeah, and Aniket, that's the kind of question I was going to ask you just in conclusion, is about the developers, what they're really wishing for. I mean, I imagine it's all those kinds of things that Sean's talking about, but from your perspective, in terms of what you're seeing out there, what would you say they'd be really wanting to see over the next 12, 18 months?
I think one theme is definitely the amount of data that people are generating. And there's increasing awareness of who's owning that data. Can you really transfer it to the cloud, or would you rather have control on it yourself? So I definitely see that processing getting pushed more to the edge, where the creator, generator of the data actually has more control on how it's consumed and monetized. Security is another very thought out feature, because nobody likes to be, I think the latest one is Jaguar Land Rover, where their IT systems are down, and it's down for many months now.
The cost of that.
And there's regulation coming in that's going to change how we think of these industrial factory settings, or even inside the car. And that's going to be a new world we'll be living in 5 to 10 years.
Well, that about concludes things. Our time is up. I want to thank Margherita, Aniket, and Sean. Thank you very much. And thank you, everyone, for being here. Really appreciate it. They're available to chat if you want.
Thank you.
Please welcome Edge Impulse co-founder and Qualcomm Senior Director Technology, Jan Youngboom.
All right, closing it out. And the last person to stand between you and happy hour. So traditionally, at least for the 3 Imagines that I was prior to this, someone would bring me a beer on stage. But that has not happened. So can I ask someone from staff to go do that? That would be great. So on July 29, 2025, about 2 months ago, something happened that I did not anticipate when I started writing the original source code for what became Edge Impulse 6 years later. This was our raw data table, the table in our database where we store all the samples that people upload. And if you are a software developer, you might think, hey, that is actually a very round number. Because on that day, we hit an overflow in some of our data. And this is the basically the max value of what fits in a int32. And stuff got on fire, and people saw things like this in the studio. And this is funny, man, because the code that was responsible for this was basically written in July 2019. It's the code that basically stores all of the samples that you have in a NumPy file while you're generating features. And at the time, I just had no idea that we would ever have more than 2 billion data samples in our database, and that we needed to start thinking about that already at that point. But here we are, man. It's truly fucking astonishing how much this community has grown. And even just from last Imagine, we have over 200,000 new projects on Edge Impulse in just a year's time. It is absolutely incredible. We have 225,000 plus developers. Yeah, as Zach said this morning already, like more than 1 billion new data samples since last Imagine, 2.3 billion today. That is 31 new samples every second of people just capturing data, accelerometer, audio, images, whatever, and uploading it to the system. It's truly astonishing. And one thing that I started tracking only since last year, the number of papers that people write mentioning Edge Impulse in Google Scholar. 1,600 now, up from 850 last year. So even in the academic spheres, people are really picking this stuff up and using Edge Impulse to write their theses, which I think is really cool. Really, really cool. Like this graph, it just keeps going faster and faster and faster. So truly, truly amazing. And everyone here, the people here in the audience, the partners, thank you so much, Linda. But yeah, everyone here, the people in the room, our partners, the people on the live stream, the people that will be watching this on demand later on YouTube, this is all you. Absolutely fantastic. So let's go look at some cool stuff that we've done over the past year, and then some new stuff that we're building, and a couple of things that we're actually shipping today. So already, oh, I thought I removed the animations, but whatever. About 6 months ago, right, and I think this is one of the reasons why you've seen the community growth this fast compared to years prior, is that the Qualcomm acquisition has allowed us to also give away a lot more stuff for free than when we were still a standalone company. So on the community plan, you know, of an hour, basically per job on compute time, we have enabled GPU training for everyone, and some of our state-of-the-art models like FOMO-AD, YOLO Pro, are now available for everyone and not just people on the enterprise side. And I think this is a really big reason why we see such an amazing pickup in our community tier and going faster and faster and faster. This is all there. If you have not tried out any of these things, you'll be able to train much bigger models and do that much faster. Now, we also shipped a whole bunch of quality of life improvements. These are the things that we normally skip over in these announcements or in these keynotes, but I think it's cool to call out. We finally have filtering on the test data page, which is, for me, such a huge step up. Thanks so much for the studio team. I heard a couple of people who built stuff. We have the Feature Explorer, which is the little widget that basically shows you data separation after your feature extraction step, is now asynchronous. So on large data sets, that will cut down the feature generation time by a minute. That's on 550,000 projects. That's a lot of minutes saved of engineering time. And we have a new nice bounding box editor to make really, really, nifty new bounding boxes where you can actually zoom. And again, when we built this initially, we thought, well, maybe people will use it to draw big boxes around beers. But now that we see customers having hundreds of labels because they're doing very complex PCB manufacturing, all of a sudden it's very nice to be able to zoom in and see all those boxes. We shipped a little dynamic threshold changing window as part of the Linux runner and our WebAssembly build. So if you want to change the threshold of, let's say, your object detection model, you don't need to go recompile your binary anymore. You can just do it dynamically. Big time saver. And then we shipped our new public project pages. So if you're looking for a data set, you're looking for a reference project, just something to get you started, you have a one-view overview of everything that's in that project. A sample of the data set, accuracy, latency, RAM and ROM info, all in one go. I think at this point we have 35,000 open projects. Just stuff that people have done and didn't keep for themselves, but actually figured, hey, this would be super useful for the rest of the community. Let me open that up. I think really awesome as well. All right, then, time series data. We also shipped two things that when I look back, I can I'm thinking like, why did it take us so long to ship this? But it's finally here. One is an optional data normalization step right after feature generation. This was never really needed because a lot of our signal processing blocks have normalization built in. Like if you build a spectrogram out of audio, well, there's already normalization in there. But as we also open this up to pre-processed features, lots of stuff where people just put in raw data, this actually is a big increase. And then for event-based time series things, like here tempering on a lock, we now allow you to say, hey, what should the label be if I'm in this window? Well, in this case, it should be temper, right? Even though it's not at the end of the label. And this actually yielded a 10% point increase in accuracy from some data sets that we do here. So that's nice. Last year, we also shipped a synthetic data UI. So this allows you to go get data from, for example, generate a bunch of keywords with Whisper, or generate non-voice audio using 11 Labs, generate images, etc., everything in your project. And it's flexible and has a pluggable architecture. And I think that's really key. Like, I want to build as Edge Impulse, right? I don't want to build everything. For the very simple reason that we cannot build everything. We don't know what is the required thing for your specific use case, but rather I want to have a pluggable interface where people can just plug stuff in. So what Globalsense talked earlier about, where they actually say, hey, we have all of these custom blocks and those plug into Edge Impulse, that is awesome. That's what I want to have, because then I don't need to go build all of this stuff myself with my team. But if you look at the synthetic data UI, there's one thing that is very clearly missing. We have stuff for audio, we have stuff for images, but nothing for other time series data. And that never sat well. And the reason that we can't do that, or couldn't do that, is because there are no big Gen AI models that can just spit out time series data. I can't ask ChatGPT to go give me some fake rotating machine anomaly data on an accelerometer. So our DSP team has worked really hard to go build a hybrid thing. So not completely synthetic, but sort of augmentation thing for time series data that we're shipping today. If you're on enterprise plan, you can use that. And rather than say, hey, I'm going to create something that's completely synthetic, we can take your current data set, your current time series data set, decompose the samples into the trend, seasonality, and noise, and then either manipulate one of those decomposed fragments of your data, or actually say, well, we're going to take the decomposed values from multiple samples and then combine them back together into completely artificial new samples. And we've rolled this out, like, we didn't just come up with this on our own. We rolled this out with a leading customer in wearable space, and we've seen actually an 8% point increase in their very challenging to collect data set with the same data just by adding, synthetically augmented time series data. So this is really cool. There's a blog post, I think, up today on how you can try this out. If you don't have an enterprise plan, go make a trial and you get access to this functionality. And I think it's going to be a real game changer if you're doing stuff with time series data on Edge Impulse today. Last year, we also shipped a PPG processing block. So, I come from an embedded background, not from a machine learning background. So my take when we're building a new machine learning algorithm is not, let's take the raw data and throw it in a really big model, and hopefully we'll figure out, the machine learning model will figure it out. It's rather, can we take a look first at what we can do with traditional signal processing, compress that data down, highlight the interesting stuff, and then we can only train a very small machine learning model, and that means we can stuff a lot more on a lot less silicon. So last year we shipped our PPG processing block. That has gotten really good pickup. It's actually in production with the first customers in really big volumes already. And now we're expanding that to also include an EEG block. So that is pre-processing specifically for EEG. It has motion artifact removal. So we already built that for PPG data. If you have a sensor on your arm and you move around a lot, you get very bad readings, which is why people are using PPG for sleep, because that's easy. You're just laying still. But it's a lot harder for motion, for people in motion. So we added this motion artifacts removal. We do this for EEG too, because it's even more sensitive to this. And then we add a new processing feature, multi-taper PSD. And together, that actually creates stuff like on top you see the same signal, an EEG signal, using sort of a traditional signal processing pipeline. And then at the bottom you see our new multi-taper PSD approach, and you very clearly see the energy in the alpha band between 8 and 12 hertz. And that's what you expect to see if you have an EEG reading. So this comes exact same signal, way clearer, and thus it's going to be a lot easier for an ML model to go pick up on what is happening here based on the data. You don't need to throw more compute at it. And of course, like everything, this comes with both an implementation in the studio, so you can test it out and get the right parameters, but it also comes with a high-performance on-device implementation. So you can roll this out on wearables, stuff behind EEG behind your ear, wherever you want to go or want to deploy that. That is available either next week or maybe a few weeks after. If you want to get early access, go talk to Dan, who's sitting over there. All right, then computer vision. So again, last year we shipped our AI labeling feature, which was sort of a first foray in how do LLMs play a role in Edge AI, if you're not straight want to run an LLM directly on device. So it's essentially a way to have LLMs or other big models help you label data. And labeling can be wide, right? It can be an image classification task. I don't want to label if this is a cat or a dog. But it can also be, draw me bounding boxes around the stuff that I think is interesting. And by chaining models together, for example, here in the picture, you see first a very generic object detector, OWLVIT, that just detects all the pills. And then we have a big LLM, a big VLM, GPT-4o here, that is then labeling these based on the text that is on the pills, which is a really complex use case. And it's going to take you a lot of time if you want to do this by yourself. Together, we can chain these things together and label these data sets a lot faster. This has seen tremendous pickup. I tried to run a query on the database to see how many labels how many samples we labeled using this. And then after half an hour, the database was still chugging along, so I don't have the exact number, but it's in the tens of millions. Next, as Zach already talked about, we're now going to bring proper full LLMs for on-device inferencing into the studio as well. So this is a sneak preview of that interface. So you can just ask stuff in natural language about your data set. And that's what we're going to do here. So we'll set the prompt, and there's an image classification task. So classify the image as cat or dog. And then rather than having to train a model yourself, you can just zero-shot it. And this will either, in this case, will get it right in all these things. And this becomes important because the fact that I can run a VLM on device does not mean that that just magically works for everything, right? I first want to evaluate how well does this actually work on the specific data set that I'm trying to classify. So for a VLM, the first thing that we're rolling out is a zero-shot understanding of image classification tasks. So just say cat or dog without actually having to train a model. We will be able to have multiple labels per sample. So that becomes more important later if we're going to talk about cascades, but the make of a car or the type of a car or the license plate. And this will be fully integrated into the studio, so you have model testing and live classification and experiments. And you can also benchmark that against models you train yourself, right? And I think that's important because how well does this VLM actually work? The VLMs that we can run on device are going to be smaller than what we are expected in sort of the big cloud VLM world. A GPT-4 with, whatever, 1 trillion parameters is going to have a way better world understanding than a 4 billion parameter model that we can run on, even sort of the highest compute devices that we have today. So understanding how well they work and in what cases they don't work is crucial. You can't just run that LLM directly on device without doing that. So the first deployment here, I see this is, I think, for me, the biggest change of being part of Qualcomm. I sent these slides off to legal, and then they added the trademark logo after Dragonwing. Are going to be on the QCS 6490. That's the same dev board that runs the car demo that we have, the racing car demo, and on IQ9, which is the new 100 TOPS device from Qualcomm. But as always, once we ship this, we will be open to other targets very soon after. All right, then, because VLMs get all the hype, but there's still 99% of our customers are not deploying VLMs on device. We started investing in our own computer vision architectures back in 2021 because we saw a gap in models that were actually built for the edge. So the first one that we did was FOMO, which is our, an object detector on the lower end that actually outputs centroids, and that runs a lot faster than these big bounding box models. Really useful. I call it a constrained model for constrained problems. In lots of cases, I want to detect if a beer bottle comes off the production line. I don't need a really big model. I can have a very small model that just needs to be trained on that specific use case. Then we shipped FOMO AD, I think in 2022, maybe 2023. And then the HD version of FOMO AD last year. This is our visual anomaly detection block. And you saw in Zach's keynote from this morning that we see really good pickup of this in all kinds of visual inspection use cases, like with MullerTech. And today, we are releasing the third one here, and that is finally, after a year after the initial announcement, YOLO Pro, which is our bounding box object detection model. And that concludes sort of our foray into new leading CV architectures. So YOLO Pro, available in Studio for everyone today, is a state-of-the-art YOLO object detection model, YOLO-style object detection model, completely developed in-house, that will allow you to do object detection on all kinds of interesting data sets. It comes with transfer learning weights available. So right now, just trained on open images, so it's good at traditional image classification or object detection tasks. But we are coming out with specialized weights soon. So you might have a model that's already base trained on an industrial data set. So if you want to deploy this somewhere in the factory, you can just fine tune on that existing model. It means you need less data and it trains faster. Very important for our customers is that this is very clean licensing. So there's no GPL and no AGPL codes in here. And this is available today in Studio. So everyone here can go try this out. Just take an existing object detection data set, create a new experiment, and go train a YOLO Pro model. It's really built for the edge because we built this completely from scratch. It also allowed us to make a bunch of choices that we found lacking in some of the other state-of-the-art object detection models. For one, the model sizes. So we can scale this from 600,000 parameters to about 35 million parameters. And just as TBD, we should have removed that. Just an indication, this can run in about 220 kilobytes of RAM in the smallest configuration. So this can even go in places where currently we can only deploy FOMO. And then on X-Large 480 by 480, on my MacBook M4 Pro, this runs 2 frames a second. That's how big that model is on the CPU. So this is really big. And then the second is that we can also turn features on and off in this model depending on the architecture that we run at. So we have a self-attention mechanism, so it's a couple of transformer layers in this architecture, but not all NPUs and accelerators support that. And because now we fully control this training pipeline, we can just disable attention if you want to go deploy this on an NPU or an accelerator where you don't have support for these transformer layers. And I think that's really cool. And we can continue building features that we can enable and disable depending on the silicon. And so today this already runs on general purpose MCU, general purpose DSP, general purpose MPU. But we also have NPU and GPU support for 6 vendors, Qualcomm, CEVA, Memoryx, ST, and NVIDIA, straight from the get-go, which I think really cool. And we're going to be adding more stuff very soon. So available today, YOLO Pro. Now you have a YOLO Pro model, and then you have another problem. So let's say that I have, this is the car detection demo, the car park demo, that's also on the show floor. This is a very well working model, in all fairness. It detects vehicles. Now, the problem is that object detection models work 1 frame at a time, right? And thus, I know that there's a vehicle, but it doesn't tell me anything. It doesn't tell me, is this a new vehicle? Was it here a frame ago? Is this box still the same box that I was looking at previously? So we shipped, about a month ago, we shipped object tracking now in Studio. And that is a flexible object tracking architecture, so a post-processing layer for object detection models. It works both in stuff that you train in Studio or stuff where you do bring your own models. So if you train something outside Studio, it works for centroids, so FOMO-style models, and it works for bounding boxes, so YOLO Pro-style models. And the only thing you need to do is basically give your object detection model, you upload a video, and then, this is the exact same video that I had before, instead of getting noisy bounding boxes every frame, I now get super clear tracking. There's vehicle with ID 0, there's vehicle with ID 6. And from frame to frame, I know that I'm looking at the exact same vehicle, which is cool. Like this big part of my application, stuff that I need to implement to make this object detection model useful, is now done for me. Now I can just write code and start thinking about, okay, my logic might be, I have an object detection model, Then through the object tracking, I know when a new vehicle is found, right? That's probably what I want to do. That's the whole reason I'm running this object detection model. And then I can, for example, chain that to the VLM, and that's sort of how we tie this all together. So now I can get free-form features from this, but just prompting a VLM. And because the way that we architect this as sort of a chain of models means that this last part, the VLM part, can, for example, take quite a lot of power because I don't need to run it every frame. I can set some rules, like I only run this VLM part when I see a new car and it's been there parked for at least 2 minutes. That's when I burn some energy. And that might be a VLM that runs locally on device, if you have a higher-end device. But it might very well be, if you have an OpenMV cam, that's the moment you say, hey, now I want to burn a bit of energy to go access to the cloud, because now I know for sure that something interesting is happening here. So you create these architectures that are sort of get the best of both worlds. They run fast and small and really power efficient on device, and then when you need the power of a VLM to catch these free-form features, that's the moment that you burn a bit of energy and go to the cloud. And these cascades are quite common, right? These are not just in computer vision tasks. Think about an MCU that's doing fault analysis. If you need to run the MCU at full capacity all the time and sampling from the accelerometer all the time, you're going to burn through quite a bit of energy. If instead you could say, well, I'm running, for example, ST has these accelerometers where you can run a decision tree directly on the accelerometer, a very small one. What if I combine that? I've run the first stage of my model on the accelerometer itself, and only the moment that I see something interesting happening there, then I wake up the MCU to do my proper fault analysis. And bam, now you're 10 times more efficient. Same with multiple computer vision applications, right? You might use object tracking to find a part on the factory line. And then you run FOMO-ID to do visual inspection on that. And because FOMO-ID doesn't need to do it on the full frame, you can have a much more efficient and smaller model because they need to learn everything about or everything around that part. It can just focus on that part specifically, so you get better accuracy. And then maybe you want to either cascade to an LLM to analyze a fault or just alert a person. Hey, I'm pretty sure that I found a fault in this part. Go take a look at this. And then there's cascades where two models just run, where one model just helps clear some stuff up for the other one, like a noise suppression neural network that you want to run before your keyword spotting model. An easy way to increase accuracy. So we are working on a couple of features. They're not live yet, but they're going to be live very soon to make building these model cascades a lot easier in Edge Impulse. So the first one is that for the first time we're allowing freeform outputs in Bring Your Own Model. So traditionally, right, in Edge Impulse you could build classification models, regression models, object detection models, and anomaly detection models. And if you have a use case like noise suppression that doesn't fit in either of those things, you cannot get it into Edge Impulse, and thus you can also not deploy it, which is sort of a pain in the ass. So with Bring Your Own Model, we'll support any inputs, any outputs. And on its own, maybe not so useful, but it's very useful once you start chaining these together in a model cascade. The second one is that we are adding proper support for running multiple models in our C++ deployments. So right now we do this ad hoc. So a customer comes to us and say, hey, I want to run these 3 models on my MCU. OK, great. Then our solutions team will go take these 3 projects and then make one library for the customer to go deploy that. A bit wasteful. Now we're going to add proper support in Studio. You say, hey, I want to deploy that impulse, that impulse, that impulse. OK, here's one library. Go run that. That's very nice. This will come probably this month. And then last, and Dan didn't want to show me this little UI because he wants to do it in code, but we're going to be building a cascade builder. So a place in the studio where you can just say, hey, this is what my cascade should look like. Here's my object detection, here's my object tracker. If I've seen the same object within a minute, I want to do the cascade to a VLM, and then evaluate that whole system rather than on a model-by-model basis. That doesn't mean you can't build any of this stuff today yet, right? It's just that we're making it a bit easier. So as an example, here is something you can just run today using YOLO Pro plus an object tracker and a VLM to do it in the cascade, which is something I put together. So I did not tell my girlfriend what we're going to do. I just asked her to walk in the room. So we have a person tracker, and that's me. And if it's seen the same person for 2 seconds, it will cascade to the VLM and then ask a free-form question. What color hair do these people have, and what color shirt do they have? And you can see, right, this runs in about 25 milliseconds per frame. So this runs very, very fast. I can detect people come in. The object tracking works really, really well. And then I still get like all the benefits of what an LLM can do. But an LLM takes 2 seconds, right? So I cannot run this in real time, because then I get 0.5 frames per second. But here, by just chaining these two things together, I get the best of both worlds, really fast, really responsive, low power on device, and then just burning a bit of energy the moment that I want to know exactly what is going on. So you can already do this. I've put examples on GitHub, both for object tracking, cascades, and for visual anomaly detection cascades. So you can just go run that today. Last, we put our very first release of model monitoring. This is sort of, I think, the last missing piece of what is in a system, right? Very often, up until about a year ago, we said, well, the moment that you deploy your model, we give you source code, you put it in your device, and now we're done, right? But if you're building a complete system, you also need to know, how does this model keep working? Is there drift in the model? Are we seeing stuff that we don't expect, etc.? And as you're building bigger systems, this becomes important. And we also see that customers can build this themselves, and they've done that in the past, but it's much more efficient if we just build it, if we build a common foundation and customers can just plug into that. So the first release of this is now, we put out internally about a month ago. And with all of these things, right, the ability to create much more complex model chains, the ability to cascade to a VLM or cascade to a human if needed, the ability to run complex computer vision models on one end, the ability to run time series models on the other end, and the ability to monitor these models, like all of that together, that brings us to our visual inspection solution, as Zach talked about. Right? So for the first time, we're not going to just be providing a platform where people can train their model, but actually a full end-to-end inspection package, including hardware, complete software that runs on-premise, something where you can just go in, deploy this to start on your factory line, and get real insights from there. I'm really, really excited, because this takes us, as Zach said this morning, it takes us from, we provide you with 20% of the solution, and you need to come up with the remaining 80%. Now we'll be able to ship 90% of the complete solution, and then have our SIs handle that last 10%. So, last that I want to say, we are launching with Hacker Earth a new AGI contest. So if all the stuff that you've seen in the last 30 minutes, you want to go apply that, you want to build something cool with YOLO Pro, you want to go put your own chains of models together, you can win money. $30,000 in total, $12,000 for the first prize. So if this sounds interesting, if you like money, go to Hacker Earth, sign up, and start doing our AGI contest. And with that, I want to thank everyone so much. There's going to be happy hour in the next room, and see you next year. Oh yeah, so there's drinks right now, literally next door. If you're still around, in an hour and a half or so, we'll have an after party at the Shashi, which is the hotel next door. So not next door, but go out of the building and then go to the other room. So cool, let's grab a drink.